So we should be live. I'm just going to double check a little bit informally here that the stream is indeed live. If you are tuning in, thank you for being here today. Oh, I hear
If you are
myself.
tuning in,
Oh yeah, we are live. Okay, excellent. So if you're tuning in here, thanks for being here today. We're going to talk about we're going to run through history of interferometry, which I know is quite belabored at this point. Might be a little redundant, but it's all set up for this discussion about Aetherdynamics and the Allais effect. If you're not familiar with the Allais effect, it was measured by Allais in 1959, I believe. 54. He was measured by Allais in 54. He had a pendulum that was precessing, and he noticed that during the solar eclipse, the pendulum started doing erratic movements and stopped precessing like normal. So, which is pretty interesting, especially when they try to claim that the pendulum precession is caused by Earth rotation. So we're going to get into that. Yeah, so I'm going to go ahead and run through Alan's presentation about interferometry, and this is going to be my first time actually going through it, other than him presenting it. So I'm just going to kind of use it as a guide to just run through the history here, but it's pretty loaded. So I'm going to try and kind of breeze through it. Hopefully I don't miss anything too important, and hopefully I don't belabor anything too much. And so yeah, I'm just going to share the PowerPoint here. All your laser interferometry now belongs to us. And we're just going to jump right in. So the whole idea was back when they did the Michelson-Morley experiment, it was, is it going to be, are we measuring an absolute reference frame of somehow using space? Basically, if you're going to try and determine relative motion and you are going to claim that the atmosphere is somehow clinging to this ball that's spinning through space, then maybe we can go a step further. We can use interferometry, because that's going to use the speed of the quote-unquote speed of light, the induction rate of light, to determine the relative velocity of where we are. And that was, they understood this at that point. There was a reason that they set up to do this experiment. So they is believing in the ether as a framework of interpretation over the space-time coordinate system of valid position. How can we logically stand on an invisible substance that we can't seem to interact with? What separates the ether from space-time? So assuming an ether wind respect to a stationary, non-rotating Earth, so it's kind of like a geocentric position, and we measured the ether at 5 kilometers per second. That's what Michelson-Morley, that's what they measured at that time. If anyone doesn't know about Michelson-Morley, actually, let's go ahead and real quick, let's pull up this interferometry explanation. Also belabored quite a bit, maybe a little bit redundant, but it's a really good place to start with understanding what we're talking about here and how this can be related into the pendulum and the ether flow. So I'm going to stop streaming that and pull this up. And here we go. Is the sound not coming through?
Yeah. If you share full screen, it won't play the sound. You have to share the window.
Oh, I thought I did. Sound. My bad.
It looks like you did, though, to be fair.
Let me just try resharing it. Let me see. Is my sound working?
Yeah.
That's weird. For some reason, I just don't get any sound from this video. Oh, yeah, it's just this video. Okay, maybe this is a soundless video. I thought this had music behind it. I swear it did. But in any case, let me just reshare. Sorry about that. So basically, I'll just explain. It emits a laser, and this mirror here splits the laser, which goes and hits 2 more mirrors. And then when it comes back, they hit the mirror again, and this mirror actually recombines these 2 beams back to point to the photodetector. And so what you need to understand here, what it's trying to illustrate here, is the phase of the light. And if any of you are familiar with speakers, with sound, like sound speakers can go in and out of phase with each other. If you're setting up like an amplifier and you have two speakers next to each other, you have to align them in a specific way, because otherwise, because both of those speakers are emitting the same sound waves, they can actually end up kind of canceling each other out if they're not aligned properly. And it could, because it's like the peaks and troughs of the waves are kind of overlapping each other. And so with an interferometer, they split the light wave, and those peaks and troughs are split. And then when they come, if there's no difference in that induction rate going to those two mirrors and coming back, then those peaks and troughs will line back up when they recombine, and you'll get you won't have any what they call it a fringe shift. It'll look exactly like it did when it was first emitted from the laser. But so here now they're going to show what a fringe shift means. So you'll see they move these back and forth to kind of show that you're splitting that part of the laser. You're increasing its the distance it needs to travel, so it's going to take longer to get back or to induct its way back to the mirror or to the splitter here. So that's how you get this different fringe shift. You see how it's going in and out of phase there. You can see, yeah, the difference. So that's how they measure the quote-unquote fringe shift, phase shift. That's what they're talking about. Now, this is just a really simple, orthogonal, like really straightforward interferometer design. You could run, after you split it here, you could run it down a coil for a fiber optic gyro. You could do like a whole coil of fiber optic cable. You could do a bunch of mirrors going back and forth that are doing more like parallel or more linear motion to just increase your distance, because the more distance that you get, the longer of an induction travel time that you have. And the longer that induction travel time is, the more sensitive that your instrument is. So that point about sensitivity is important, because this was, with Michelson-Morley, it was supposed to be sensitive enough to detect down to 2 kilometers a second. And if we're moving through space at the rate that they say, it should have picked up like 30 kilometers a second. So let's go back now to the PowerPoint. And I'll just try and really breeze through this here. So yeah, basically the idea here then is that the main, there's two ways you can go with this when you're detecting this fringe shift, right? You're either going to detect, there's two ways to interpret this relative motion. Either the ether itself is drifting and you're stationary, or you're drifting and the ether itself is stationary. Especially once you actually measured it, that's actually the only two conclusions that you have, and you would have to be drifting at a strange pace that's not in line with the linear motion that their heliocentric model would present to us, right? Like maybe you could draw up some whole new model where we have this insanely slow drift rate that's like relative to the rest of the motion in the cosmos, but I have never heard anyone present anything like that. Some people have tried to present this idea of a fixed ether, like a relative fixed ether, but it's just as nonsensical as a relative fixed atmosphere. You have the same problem of the gas and containment. In any case, moving on. Here's some more examples of interferometer setup. So this one looks a lot like what we just watched, a really basic setup here. Some more setups. Here, this one is using fiber optic cable, like I was talking about. Yeah, and so it's the one measurable difference in their model between heliocentrism and geocentrism, because they try to say, like I was saying about relative motion, if we're trying to measure it, this is like the one, like this is the concrete way to measure it. So. Prerequisite, relativistic interpretation of light. So this comes up because of what they couldn't measure, right? This whole relativity thing, if they had measured a relative velocity through the ether, then they would have been all good with it. They would have said, there we go, we're moving. We can feel good. God's not real. We can be on our spinning space ball and have everything be relative, or have everything be separated from each other. But that didn't happen, so they had to come up with this. They had to, you know, everything wraps around one deception, right? And once you're stuck on that deception, you got to just keep winding it around more and more and more deceptions. So special relativity is the framework through which laser interferometry results are interpreted. That's interesting. Special relativity postulates. The first postulate is that the principle of relativity in an inertial frame, the laws of physics, are the same for all observers in uniform motion, regardless of their velocity. This postulate asserts that the fundamental laws of physics, such as those governing the motion of objects and the behavior of light, remain unchanged for observers in different inertial reference frames moving at constant velocities relative to each other. So right here on its face, we already have a major problem because we're picking up an actual ether drift. And so what they have to do with that is say that, oh, well, it's somehow we are picking up some kind of relative rotation of the Earth. It's absolutely nonsensical to claim that this has anything to do with rotation. Second postulate, the constancy of the quote-unquote speed of light. The speed of light in a vacuum, c, is constant and is independent of the motion of the source of the observer. So everything, the observer, what they're actually seeing is not going to matter. Hold on, I'm going to switch to streamer mode here so I don't get distracted. Where is this? Where's streamer mode? Here we go. All right, cool. Sorry about that. So second postulate, this postulate states that the speed of light denoted as c remains the same for all observers, regardless of their relative motion. So if I'm going down if I'm somehow traveling 1,000,000 miles per hour and you're sitting there stationary and someone flashes a light at us, we're going to see it at the exact same rate no matter what. It's debunked on its face by relative simultaneity. The idea that if lightning strikes and two people are on a train and they see that lightning at different times, even though they're on the same train, they try to use some kind of Doppler shift magic, but it's not. It doesn't work like that. There's relative simultaneity is demonstrable, and it's really, really, really just dead on its face once you consider the Sagnac effect. Under the relativistic framework, C is invariant, and thus the fringe patterns are a result of length contraction of the apparatus itself. So, C is invariant. The speed of light cannot change. So, even though we're sitting here measuring, the whole premise of this device is to measure variance in speed of light. What we're measuring is a result of length contraction of the apparatus itself. And they've been forced to take this all the way down to the local level, thanks to Wang in 2004 and Marinov in 1984, even though they don't even, that's been buried completely. We'll talk about that later on. So this is crazy. If light is made up of ether, then there will be no tailwind or drag. And the history of changes to Maxwell's equations. I don't know about this subnote. I'm going to skip past here. So yeah, they're called interferometers because they work by merging two or more sources of light to create an interference pattern which can be measured and analyzed, hence interferometer. Oh, I never knew that. Okay, cool. Moving through. We won't get too into the weeds on this. This is talking about interference patterns and kind of what I was trying to explain earlier about things being in and out of phase. Yeah. Oh, whoops. More about fringe shifts. This would be a lot to go through here. We can talk about this later if you guys have questions about it. Area success. So basically, they tried to use water in a telescope to determine relative velocity speeds using refraction rates. And the idea was if they had to tilt the telescope, then the Earth would be. If they had to tilt the telescope, then the Earth was moving, right? Isn't that what it was? And then essentially It was the opposite of what they expected. They didn't have to tilt the telescope, meaning that the light was already coming in at the proper velocity. Which means that we are not moving. So kind of hilarious that they already had done this in 1871. They're just like looking for any way to I don't know why they even. Yeah. Well, go ahead.
Well, quick quick, additional information on Airy's failure, right? Because a lot of people will say that he failed to prove the Æther, or he failed this or that, right? Like there's multiple quote unquote mainstream interpretations of it, but he didn't. The fact that he didn't have to correct it is like everyone knew that what that meant. There's a paper by William Well in 1898, where he states 10 experiments that failed to prove Earth's velocity, and 2 that did, right. And Airy's failure is on the ones that failed, right? Like they all knew, right? So when people talk about it now and they're like, "Oh no, it failed for this or that because Wikipedia," no, everyone knew, right? Like let's just like it's very clear. If they had to adjust the telescope, then that meant the Earth would be moving, right? Like that was the difference. So it's very. That's why they leave it so ambiguous and just like refer to Wikipedia, and you have to go back. So like even what I wanted to point out here in the Michelson paper is he makes a special note on it saying that like this is hard to explain for both theories where the Earth is in motion, for no matter how you want to look at the movement of light.
Cool.
So, yep.
Yeah, so moving through, I already kind of talked about Michelson-Morley, 1887. So yeah, just Airy's success was 1871, or Airy's failure as they call it, because it failed to detect motion. But it did succeed in proving that we are stationary. Michelson-Morley, 1887. The heliocentric prediction of the orbital velocity is 30 kilometers a second, corresponding to a 0.4 of a fringe displacement, and a fringe shift corresponding to around 5 kilometers per second on the low end, and 7.5 kilometers per second on the upper end is what they actually got. So that's not, that's not orbital velocity. But in this particular experiment, they just ignored it. They just ignored this part. And they called it instrumental error. But they did say there was no instrumental error as far as the whole device contracted and we weren't able to get anything. But this was instrumental error. So, just take what you want. If they had gotten what they wanted, they would have taken it. They didn't get what they wanted, and they're like, instrumental error. Michelson-Morley length contraction in Æther, 1888 to 1892. In the late 1880s, Hendrik Lorentz and George Fitzgerald proposed length contraction as the mechanism that explains why the Michelson-Morley experiment failed to detect the Earth's motion through the stationary Æther, suggesting that the Æther contracted the apparatus in the direction of motion, physically or apparently shrinking the length of the arm. So at that point, they were actually still believing in Æther, and they're like, well, maybe the pressure of the Æther itself pushed up against it and contracted it. That's that. In 1905, Einstein offered new insight with the two postulates of SR, which we already went over earlier. So that's how they tried to claim their null result. Michelson-Gill-Pearson at 41 degrees north parallel, a fringe shift pattern consistent with Earth's sidereal rotation was detected. Let's examine the mathematic framework used to extrapolate globular results. Michelson derived his equations from classical wave mechanics and assuming an absolute reference frame to measure the varying velocity of light by considering that velocity of light as v minus v in west to east direction and v plus v in the east to west direction, where v represents the speed of light in a vacuum and v represents the linear velocity of the Earth's surface. Michelson suggests that the speed of light is not uniform across all inertial frames of reference. Yeah, I mean, that's what I'm saying earlier. Like, they try to claim this rotation thing, but that on its face is insane. How can they say that with rotation? They try to say it's some kind of relative rotation that they can measure, but that means speed of light's not constant.
Yeah, they had to make it a special case and, and just say, well, it's a non-inertial frame. And then for other experiments where it's obvious that it's stationary, they'd say, well, it's like locally stationary, or whatever, right? So it's crazy, dude. But yeah, on the face of it, the experiment shows a variance in C. So that's why they had to make it explicitly due to rotational effects, because of the way that they had to explain the Sagnac effect in 1913, which on the face of it refuted special relativity.
Yeah, so then Sagnac came along in 1930, and he did a yeah, the interferometer consisted of a split beam of light that traveled around a horizontal circuit, and then he rotated. So you take kind of what we were looking at earlier, the animation that we watched, and you rotate that, and then he created a relative motion, and that he called that a hypothetical ether. And basically, what they are able to detect in the fringe shift is a direct proportional relationship of that rotating motion to the fringe shift of the lasers, or of the laser that goes out and recombines. And that, again, on its face is an utter refutation to special relativity because it's C plus V. So I won't spend too much time on this at the moment. We'll keep moving here. But just the important thing to note here is that this happened locally on his device. He rotated his device, and he saw a fringe shift relative to that rotation velocity. So he's doing it right there on a local scale, showing that C plus V measurement. It's not just an ether wind that they're going to claim as Earth rotation. It's happening locally in front of him. Anything else, Alan?
Yeah, I put a diagram in chat that I. Oh, there it is in the slide there. That's good
cool.
enough. So yeah, that's just what the device looks like. So it's the path of light, or in a closed loop in a rotating platform.
Yep. And it also
rotating
platform. It's funny, this diagram's funny to look at because it really kind of shows what Einstein was saying. What is it that Einstein said about the circle, the rotation motion?
Yeah, so any closed polygonal loop in uniform rotation is good enough. Where Newton's equations hold true is an inertial frame, and that logically tracks because if you take any closed polygonal circuit, extend it to infinity, you're not going to deviate from linear motion. So they consider that it logically tracks, right? So on the face of it, what Sagnac showed is that in an inertial frame, the speed of light varies proportional to the relative motion of the device. So there's a first order dependence on that rotation that's predictable and all that, right? So those fringe shift patterns, when you add them up, the distance that they create, you ratio that with the speed of light, and that gives you the velocity of the device.
Perfect. Thank you.
Yeah.
Yeah, so we'll just keep moving through here. Be easy to go into the weeds on that. Relativistic explanations for the Sagnac effect. So yeah, here's them trying to talk about what we were kind of saying there with the rotation. The acceleration due to the rotation of the disk is similar to gravitational acceleration. The offset of the arrival of the light beams corresponds to the time difference which is imposed between the clocks in a gravitational field. In its own frame of reference, the speed of the photon is always equal to c, speed of light in a vacuum, when it is measured in clean time. But this clean time cannot be that of a rotating disk, hence the shift. This dilation of time induces relativity's simultaneity. So let's just recap. We're talking about a little rotating device and the fringe shift the fringe displacement that's happening on a little rotating device. And he's saying that time shifted, and that's why you're measuring the relative velocity. You're getting a direct proportional relationship of the relative velocity, and this dude's sitting here telling you that what happened in front of your face did not happen, time dilated, and made it look like it happened. So let's move on.
There's a let's see. So the apparently happens to electrons in neutrons. So that's that's the Thomson precession. So
yeah.
If you wanted to get in, or I don't know how far you wanted to get
into
No.
Maybe we can get into that later, but
okay.
I want to get through this as fast as possible so we can get into the other stuff.
Okay, cool.
So yeah. But yeah, later on maybe.
Yep.
So yeah, 2004, Wang came along, and we've been going over this a lot over the last couple weeks. Basically, Wang, so they claimed this rotation anomaly thing. They try to take rotation as like a special case, and then Wang's like, all right, well then let's just do specifically linear measurements. Let's do linear velocities. and that way you can't say it's just rotation. He made his own special fiber optic setups. 2003, he made his own special fiber optic setups that had linear portions, and those linear portions directly contributed to the measured fringe shift. So then from there, he put in for preliminary work for a patent in 2004, January. And then later on in 2004, he got multi-million-dollar interferometers from the Navy and a bunch of air core and glass core fiber, and did more experiments of the exact same thing, but just, more different configurations, just more and more showing direct proportional linear velocity relationships with the motion of his air core fiber and glass core fiber and FOGs in general. And so they had to come along and say the same thing basically with that. They came along and actually I won't go into the weeds on weighing too much, but we've been really belaboring that lately. But the point is, he showed direct linear velocity being measured. It's the same thing that Marinov showed in 1984. And moving on. And if that's the case, then they can't claim its rotation speed, because we have to be able to detect their orbital velocity, let alone their galactic speed. 15 degrees per hour. In the case of a rotating ether or the Earth's rotation, the Sagnac effect would result in a fringe shift that corresponds to the rotational speed. However, it is important to note that the Sagnac effect by itself cannot distinguish between different causes of rotational motion. It measures the relative velocity, but does not provide direct information about the nature of the motion or whether it is due to a rotating ether or the Earth's rotation. So this is just talking more about relative motion. How can we assert that the ether is not, or that it's not an ether rotating and that it's the Earth rotating? We've gone over and over again. The whole assertion falls bunk on its face, or falls flat on its face, because you're leaving out the orbital velocity. So Michelson, Gale Pearson, 1925. Just real quick, I think a lot of us are already familiar with a lot of this stuff, so I'm just trying to breeze through it all. But they took another big interferometer, and this time they knew they were going to be measuring a fringe shift. And when was Miller? Yeah, so they already had like hints coming in from what Miller had done. Oh, whoops. They already had hints getting into this coming from what Miller had done. They knew about the quote-unquote instrumental error that Einstein had measured, or that they had measured at Michelson-Morley. And so they just called it Earth rotation. They measured the same thing with more precision. They, a more sensitive instrument, and they called it Earth rotation. But like I was saying earlier with Dayton Miller, so Dayton Miller saw the same thing that they had measured with at Michelson-Morley, the quote-unquote instrumental error, and he conducted the most extensive experimentation using a laser interferometer during the early to mid-1900s, conducting a total of 5,200,000 measurements. He was able to determine a direct cause and effect relationship with the speed of the ether, the movement of the sun, and the axial tilt of the cosmic microwave background. The fringe shift patterns reached their minimum and maximum dimensions in accordance with the equinoxes. So if it's rotational velocity, that makes no sense whatsoever. This is directly relating to a translation of motion from the sky to the Earth. The subsequent Michelson-Morley experiments in modern times are trending towards zero, only to further prove Miller's hypothesis. As you get closer to the surface of the Earth, less motion will be translated than at altitude. He also made consideration for the environment of the apparatus, i.e. enclosed material shielding, etc. And this, we're going to get really deep into this tonight, because that's what the Gaelev paper is kind of all about. For this reason, Miller's later work consisted of taking measurements at altitude. This allowed him to make consistent measurements of the fluctuation in ether speed. So just to touch on that again, Miller he made consideration for the environment of the apparatus, thinking like Miller saw the instrumental error that they had measured, and he saw talking about the same thing that Michelson, Gale Pearson had measured, and he wanted to get specific about it, so he He actually looked at what they're measuring. He didn't want a null result. He wasn't trying to bring it to null. He was looking at what's really happening, the physical actual effect of the fringe shift, and he's studying it. And so for that reason, he wanted to accentuate it. He wanted to get more sensitive measurements of it. He didn't want to cover it with metal shielding or dielectric shielding because, as it turns out, as Gaelev has shown us now, those things, or Gaelev, I'm not sure exactly how to say that, he has shown us that those specific things actually specifically shield against measurable ether winds. So Miller was going in the opposite direction. Every time you hear someone saying, "Oh, they can't measure it; it's a null result," something like that, or if it's interesting, you look at their interferometries, like their interferometers. They have LIGO and Ginger. Ginger, they just say they're measuring precessions, and then but at LIGO, it's underground, and so although they're getting real measurements of some things, they're able to ignore a lot of things, and even the stuff that they do pick out of that is already all lost in the convolutional neural network, where it's all abstracted anyways. But in any case, Miller was looking at it, looking at the actual effect. Everything else that you see nowadays in modern days is to wash this exact effect out. They either call it rotation or they wash it out. So he's looking at it, and he's trying to go the opposite direction with the shielding. He's going the opposite direction. He's not going underground with it, covering it in metal. He's going up to observatories and putting it in temperature-controlled rooms and doing his measurements that way. So.
Was that slide about the basement thing?
So, Dayton Miller's control experiments, 1902 to 1933. It should be noted that while Miller was alive, his work could not be refuted. Miller undertook extensive control experiments and procedures to guard against laboratory artifacts and objectively determine the sensitivity of his apparatus to external influences. These things are insanely sensitive. Like, I can't remember which experiment it was I was looking at, but I was looking at one where they were saying that like the steps outside of the building could be picked up. And that's what they say at LIGO too. They try to make claims that they can they can pick through the different noise to determine what's what, but that's a whole nother rabbit hole. Setting screws with fine threads were used to adjust the mirrors of the interferometer. The final adjustment could be isolate 100 wavelengths of light by just a 16-degree turn of the screw. Minimizing mechanical vibrations. Care was taken to prevent distortions from mechanical vibrations. The interferometer was gently pulled in a circle by a thin string, slowly accelerated to the desired velocity of rotation while floating in a mercury tank. And man, like this stuff, yeah, when we get into the pendulums in a bit, it's just like there's so many considerations with these things that you really need to be kind of critical of what's going on with everything when they're even when we on our end when we're claiming to measure ether wind, what's really happening there. It's important to be skeptical. He guarded against magnetostriction. He made one of aluminum and brass. Evaluated mechanical vibrations, so he assessed it separately to make sure there wasn't something like that going on. At the end of the day, you can say all you want about instrumental error, about him not taking into account certain parameters and this and that, and there's always going to be controls that you're going to miss, especially with brand new experimentation like this. But the fact that he was able to go through the measurements and show the correlation with the equinoxes, which then the data was combed through even further by Gaelev, and he showed even stronger correlation with equinoxes and sidereal time, both. It doesn't really, like, this is all, like, maybe you could say some of this stuff affected the measurements. Actually, almost absolutely it did in some ways, but to say that that's why we would measure a correlation with the equinoxes, like, come on. Shanklin's bias, former student of Miller, later became a proponent of Einstein's relativity. He built his career on publications that misrepresented the Michelson-Morley experiments. Isn't it funny how you can do that? As solid evidence against the existence of an ether, the bias raises questions about the objectivity of Shanklin and his team as reviewers of Miller's work. So Shanklin falsely claimed that all trials of the Michelson-Morley experiments, except those carried out by Miller, yielded null results. This misrepresentation ignores the slight positive results obtained from several other interferometer experiments, suggesting a deliberate bias against Miller's findings. And again, what about the correlation with the equinoxes? Lack of comprehensive evaluation. Shanklin's paper gave the impression of a comprehensive review of Miller's interferometer observations, but it was limited in scope, blah, blah, blah. I'm not gonna spend too long on this anymore because I think we were kind of getting the idea. Let's see if we can get into specifically about the correlations he was drawing, or his work drew. So yeah, the Shanklin team focused on temperature artifacts, but did not thoroughly analyze Miller's crucial Mount Wilson data. Interesting. I mean, that's as far as I understand, seems to be kind of where all the nuggets are, and that's where what he was doing. But didn't he do measurements there for like 2-3 years, Alan?
That's where he did his best work. So that was like through 1924 through 26, something like that. And that was after, he had been doing it for like 20 years, right? So he had all this experience, all these calibrations. He knew the instruments in and out. So yeah, that was his prime time. Those measurements there.
Yeah, and by the way, Miller's measurements are not so easy to get your hands on. So if you are hearing anybody say that they've looked at Miller's measurements and they were bunk or something, you should be highly skeptical of them, because it actually seems that these measurements are being gatekept, as far as I can tell. And there were papers written by very reputable physicists that were analyzing the data and corroborating Miller's conclusions. This isn't like there's a reason that Einstein said that if Miller's measurements are real, then then relativity's in trouble, because they were substantial. So here we go. From Dayton Miller's Mount Wilson ether drift experiments, the ones that Shanklin didn't even want to talk about. 1925 to 1926. Top graph above plots data from 4 separate months or epochs, measured at different times of the year and organized by sidereal time, showing a definitive periodic curve. The heavy line is the mean of all 4 epochs. The bottom graph above plots the same data organized by several clock time coordinates. Here, the plotted data spreads out along the graph without apparent periodicity. This demonstrates that the detected axis and periodicity of ether drift is the same for different times of the year, but can only be seen when the data is viewed with a cosmological sidereal coordinate system. These data curves are organized along azimuthal means that were later recomputed for Miller's 1933 publication, as given in Figure 10. So again, you can't explain that with rotation. That's not how that works. Average velocity and azimuth of global ether drift from Dayton Miller's Mount Wilson ether drift experiments in 1925, 1926. Variations in observed magnitude of ether drift from all 4 epochs of measurement. Maximum velocity occurs at about 5 hours sidereal time, and minimum velocity occurs at about 17 hours sidereal time. Try and not read everything here. Average variations in observed azimuth readings according to sidereal time. This graph uses the same average data curve from Figure 11, but at the time was given a different baseline average. The same graph is presented here for the revised seasonal averages as published in 1933, which helped define the axis of ether drift. Amazingly, independent averages for the 4 epochs provided by Miller together yield a mean displacement 23.75 degrees east of north. This is close to the Earth's axial tilt of 23.5 and can hardly be coincidental. More discussion is in DeMeo. So just kind of going back to the same thing about it correlating with equinoxes. So a model constructed by Miller displaying the axis of ether drift for the 4 seasonal epochs of Earth moving around the sun. The axis of drift in this model appears to be roughly perpendicular to the plane of the ecliptic. Michelson Morley, the cover-up, the experiments of Dayton C. Miller, and the theory of relativity. So Maurice Allais, we'll get into him a bit more in a bit, independent of review of Miller's work, analyzed the symmetry represented in Miller's data, specifically analyzed the Mount Wilson data, which Shanklin had ignored. Finally, the figures changed gradually from one period to another. They attain their maximum dimensions around September 21st, which corresponds to the autumn equinox, and their minimum dimensions around March 21st, which corresponding to the spring equinox. They are therefore dependent on the Earth's position in its orbit around the sun. So, that's really well phrased, because it kind of puts this whole thing back to brings it back, right? They say we're measuring Earth rotation. If we're measuring a direct, they're going to say 15 degrees per hour, thanks Bob, or whatever. If we're measuring a direct Earth rotation of 15 degrees per hour, then they can't have this. This can't happen. It's corresponding to the spring. They are therefore dependent on the Earth's orbit position in its orbit around the sun. That is incoherent in their model. So, moving on. So, which just to bring it back to the whole point of this whole presentation, there's something is being measured, and it correlates to the sky. My Theory and Miller's Experiments by Professor Albert Einstein. I'm just going to skip to the bottom here. To summarize, if you, dear reader, wanted to use this interesting scientific situation to make a bet, I recommend you bet that Miller's experiments will prove faulty, or that his results have nothing to do with an ether wind. I myself would be quite happy to put my money on that. Okay, well, that's very meaningless. Never mind. I don't really care about Einstein's opinion. I would rather know about his substantial points.
Yeah, he never had any. So that's him addressing it in a way he just hand wave dismisses it, never really talks about it. and he has a history of that, right? So never addressed Sagnac, never addressed Miller. Let's see, there was another one too recently I found.
Well, I'll just move on here.
He wrote later in his life a second time about it after that first letter, right?
Yeah, he co-ops so there's while Miller's doing his experiments, the mainstream narrative is that Miller doesn't know about temperature differentials. So there's a couple. We'll see if I can pull them up while Toby continues.
Hey, yeah, you want to actually take over for a second? I'm gonna step away for a second.
Yeah, give me 1 second. Let's see. PowerPoint.
It's perfect time if you wanted to share something.
Yep. I will look for it.
And yeah, I'm probably gonna actually jump off from there after you show this. We can go ahead and move on. I think that kind of caught us up perfectly.
It's just a newspaper clip of Einstein saying that he thinks that Miller's doesn't know how to account for temperature differentials, and then Miller challenges him to a debate, and then Einstein never responds.
Ooh, yeah, well, that would be great to see.
Yeah, I'll keep looking for it. You just continue.
Cool. I will be right back.
Okay, so I'm looking for it still myself.
Yeah.
Oh, here we go. I think this is it.
So when you know what would be interesting that I just thought about not that long ago was about, you know how the normies that try to defend relativity claim that relativistic corrections are being used in these various forms of technology, and GPS is one of the ones they claim, and then we found out it's actually a Sagnac correction. You know what would be interesting is to go find some of these pieces of technology and go in to the part where they do the relativistic corrections and just replace that with a classical mechanics version of Sagnac correction and see if the results come out like the exact same.
Well, the adjustments that they're making for the relativistic and general relativistic side now are so minute because like they pretty much say that they almost cancel each other out. So yeah, like what they do account for is like you wouldn't be able to distinguish that from a classical correction anyway, just from like, whatever sort of what you call it, electromagnetic retardation, like whatever like relative motion, through that uh like whatever would cause that, like that adjustments, like it would just like you would never be able to distinguish that from a relativistic effect in any meaningful way. Because what I found was I'll just screen share, when I started looking into GPS and all that, I just recently found this paper that came out in the 90s that was like, hey, there was like engineers and stuff asking like, hey, where's the relativistic corrections at in GPS? And the paper was like, well, special and general relativity pretty much cancel out, and the accuracy required right now, we don't need to do it, but we'll do it later. It's crazy, dude.
What?
Yeah.
They told them they weren't really doing it,
Yeah, check it out. Check it out.
even though they're doing it.
Well,
They're
not at
doing
the time.
Sagnac.
No. Well, they've been doing Sagnac the whole time, right?
Yeah,
But
that's what I'm saying.
this guy, yeah, people were asking in the 90s. They were like, "Hey, where's all the general and special relativity corrections?" So, because they weren't doing it,
Right.
and this is like, so this is the official response, like apologist, put newsletter, right? Where they're like, "Hey, guys, relax. Special and general relativity pretty much cancel each other out for the accuracy that we're using it. It's fine. When we get into, dude, and then when we get into, when we upgrade our infrastructure or whatever and get it more accurate or whatever, right? We'll start having to account for these effects, right? So this is like a promissory note, like, hey, we'll Lorentz transform later, and then down here at the bottom, there's this really special letter from shout out to Carol Allais from the atomic clock experiment following the Heffel and Keating experiment, which was a disaster for proving that atomic clocks adhere to Einstein synchronization. Now, Carol Allais had a little more success and got the clocks to sync for 14 hours at the longest, so well done. But but atomic clocks are unfortunately account for the Sagnac effect and they're not synced to Einstein relativity. It's actually incompatible, which was pointed out by Paul Marmot. So anyway, Carol here, 1995, is writing to the GPS people that are in charge of the protocols and whatnots, right? And he's like, and that if one perhaps does the explicit recognition of the special relativistic effects, I mean, it took a long time to get the general relativity down properly, but I think that it is more or less correct now. But it is, but it's the absence of any explicit acknowledgement of the special relativistic effects due to the speed of light being the same whenever measured by an observer, leading to the relativity of simultaneity and the associated Lorentz transformation physics. There's nothing of that modeled in the current system, and I think it ought to be. Thank you. So what he's saying here is, hey man, I worked really hard doing my transformations and learning my maths, and I think you should incorporate it into the technology, even though it's not needed for it to function.
Yeah. Apparently, it's not using it and it's working somehow, right?
Yep. And then
Who was the person? Oh, sorry.
Yes. Sorry. I was going to say to end on that, though, we were talking to someone who's familiar with satellite work directly, and they were saying that the Sagnac correction that they apply is explicitly different than any other sort of velocity correction that they normally apply. And if you don't account for it, then you will be off by 30 meters, which is, they can, it's provable, right? But
that's what I was about to ask. Yeah, bro. Who is that guy?
Eric.
Okay.
But the thing is, there's a special relativistic correction, that they say, which is a velocity correction, and if Earth's rotation was needed to be accounted for, it would be you could account for it in that velocity correction for special relativity, but they don't, and they're actually using a different sort of Lorentz transformation where it rotates the coordinate system itself, which was apparently some type of transformation that was pioneered by what was his name? Something Thompson with Thompson precession.
Oh yeah.
So basically, it's an adjustment to the coordinate system itself, and it's not even it's not a velocity correction. It has nothing to do with velocity.
Well, you could also just do a couple Lorentz boosts instead.
Yeah. Well, it's a Lorentz. What was the other one? A Lorentz boost and
you either do two Lorentz boosts, or you do a Lorentz
rotation.
transformation and a rotation of the coordinate system.
Yeah, a Lorentz rotation is equivalent to two Lorentz boost. So that's very cool. Shout out to Thompson. All right, so here's another problem with relativity of simultaneity. So they say that an emergent property of c being the speed being a constant in all reference frames is that sometimes there's not a cohesive chain of events for observers in relative motion to one another. So what that means is GPS would have to like constantly correct for that sort of thing, that relative motion difference, like if it was like physically manifesting in reality, like if time was actually changing dependent on the observer, right? But there's not. GPS syncs to GPS time, which is kept by the atomic clocks, so it's all sync to a cohesive timeline. So when you have multiple GPS recipients on a train car that's moving, and they're getting a signal from a quote-unquote GPS satellite, and they're getting a signal from a DGPS station at the same time, they all get their signals. It's all cohesive in the timeline. The distances derived is all accurate. There's no corrections needed. There's no it's a direct contradiction to the philosophical
relative simultaneity.
Yeah, because that's like a core tenet. Like you need that has to be physically manifest if you're even gonna accept a Lorentz transformation. If you were looking at GPS and you were like, dude, why does nothing make sense? Why can't we figure this out? And then they were like, oh, we have to count for relative simultaneity. Like that would be one thing, right? But that didn't happen. It just works, which implies there's an absolute space, and absolute time.
Yeah, and so just to tie this in with the presentation here, that means those are one-way range measurement equations that are used, and so that's one-way directionality induction rate of light in an absolute reference frame of Earth rotation. They say, like, how do you can't have Earth rotation be your reference frame? That's like when it's a relative rotational motion, but you're measuring like a proportional velocity in the one-way directionality of or the one-way velocity of induction rate of light. You are debunking yourself, and that's right there in the GPS stuff. Just another example showing an absolute ether. Yeah.
Well said.
Can I pick back up here with Gaelev then?
Yeah,
absolutely.
I have one more question. Don't they use the ECI reference frame, which is an inertial reference frame, but then make a Sagnac correction, but say it's not a Sagnac effect, but you can't have a Sagnac correction in an inertial frame that they use?
Oh, snap. You're nasty. Well, I guess they would just say that the ECI is a hypothetical frame, right? Though.
Well, it's also translated into an ECEF, which is also an Earth fixed frame.
So they're actually in like a really big problem too, because their satellite freefall is considered an inertial frame as well. So their measurement is taken from dude, it's bad all around, bro.
Yeah, because any closed loop would, like, the overall angular offset would be removed. It would zero out because it's a closed loop, so it would act like it's an inertial measurement anyway, even if you didn't like create a reference frame that was inertial. And that's like the concept of WANG 04, right? Because it's a closed loop fiber optic cable. But anyways, yeah, dude, an inertial frame can't use a Sagnac effect because that's like an axiomatic violation of special relativity.
Yep.
Yeah, and then
Yep.
So I mean, they literally just get people with that. So that variance in the speed of light that produces that accurate distance They swoop that up with what they're calling a Sagnac correction, which has a 2% deviation. So whatever speed of light variance is measured, proportional to the velocities, etc., gets swooped up in that correction, and that's what goes on all the back ends of all the GPS um, data storage places.
Yeah, by the time it gets pushed out to your machine, it's already like done the conversion.
Yep,
And you
it's
get the
already
post.
it's already Sagnac corrected. So it would what that means is it would prevent people from using GPS to accurately determine distances from a coordinate because it's always going to match the coordinate system that we're told it does. So if that coordinate system was in question, you would not be able to use GPS to invalidate it. If you were, you know what I'm saying?
Bro,
you would
all you'd
have to use.
do. Oh, sorry.
Go ahead.
All you'd have to do if you wanted that number, though, is have a tracker with the GPS location data on it and time data on it, right? And compare that with your phone data and just do like reverse the Sagnac.
Yo, guys, I really like this conversation, but we haven't even gotten to the pendulum yet.
Sorry, bro.
We're already
Sorry.
hour and 10 minutes in.
My
And
bad.
we did call this Allais Effect, so it'd be good to get to the pendulum at some point here.
Yep,
we can circle back to this at the end if that's cool.
Yep.
It's super relevant, so like I hate to cut you guys off because it is directly relevant, but I just want to get through the rest of this stuff. So this paper here is the measuring of ether drift velocity and kinematic ether viscosity within optical waves band. So this ties in directly with the whole Miller thing because what they're testing here is basically how are you going to measure the ether drift? How viscous is it? Does it go through metal? Does it go through dielectric metals? Let's find out. So they used millimeter radio waves band by the phase method. It's still like kind of a interferometer that you're used to, sort of. The detector is not at the same place as the emitter, but it's still going through mirrors. This here is their basically their ether velocity testing apparatus. So moving through here. So it has the proposed viscous and course Eduskovsky had introduced the material medium composed of separate particles that fills the world space, has properties of viscous and coercible gas. Then he brings up Miller, 1922 to 1926. The measured ether drift parameters mismatched to the ether imaginations available at that time. So people just refused to accept what was being measured. Miller obtained that the ether drift velocity at the height of 265 meters above sea level has a value of about 3 kilometers per second, and at the height of 1830 meters at Mount Wilson, about 10 kilometers per second. The apex coordinates, the solar system movement, were determined. Direct ascension at alpha approximately 17.5 degrees per hour. Declination of, what's this one called again? Epsilon, approximately plus 65 degrees. Moving on. In this case, the boundary layer in which the ether movement velocity increases with the height grown above the Earth's surface is formed at the relative movement of the solar system and the ether near the relative movement of the solar system and the ether near the Earth's surface. So, kind of going back to what we were saying earlier, this is like relative to what they claim to be our orbital motion, not relative to what they claim to be our rotational motion, especially when you're going up to the top of a mountain and you go from 15 degrees per hour to 17.5 degrees per hour. Can be explained by the wave propagation phenomena in the moving medium of a space origin with a vertical velocity gradient in this medium stream near the Earth's surface. So they're talking specifically about like our area of inhabitants, and he's saying that there's a gradient as you go up. There's a velocity gradient, and the gradient layer availability can be explained by the medium viscosity proper to material media. So material media is, or the ether wind is relative to the material media that it is interacting with. The place distinctions of geographic latitudes and their heights above sea level are taken into account in these experiments, conducting a comparison. This next part, I'm still trying to wrap my head around it. So here, I'll just read it. It is obtained that in this experiment, the ether drift velocity is within 6,124 and 8,490 meters per second. That, according to the value order, coincide with the data of the works, and which are within 6,000 and 10,000 meters per second.
He's referring to Miller there.
Oh, Miller came with that.
Yeah, so Miller is 7 through 10.
Oh, okay. So, but did he derive that from Miller, or did Miller assert that?
Yeah, so Miller's measurements were like 6 to 10, because it's like you can read different references. People average it out differently. It'll be like 6 to 10, 8 to 12, that kind of thing. So 6 to 10 is about Millerish, and then he's saying that he measured 6 to 8.
Gotcha.
So he's saying he's within Miller range.
The comparison result can be considered as mutual truthfulness, confirmation of the experiments. Positive results of 3 experiments give the basis to consider the effects detected in these experiments as medium movement developments responsible for electromagnetic waves propagation. Such medium was called as the ether at the times of Maxwell, Michelson, and earlier. So, kind of just going back to this is what we used to think. The measurement results within millimeter radio waves band can be considered as the experimental hypothesis confirmation of the material medium existence in nature, such as the ether. Ether drift problem in an optical waves band. So yeah, he's just acknowledging ether drift essentially. Optical interferometers manufactured according to the cruciform Michelson schema. Passing in a forward direction, returning to the observing point along the same path. So he's just going over the Michelson-Morley interferometer, and that its sensitivity was low to the original ether drift effects. So going back to this is what Miller figured out. The interference pattern is proportional to velocity ratio quadrant of the ether drift. So here we've got velocity c, the ether drift w, speed of light, and the length of electromagnetic emission, delta. We can call the interval, so the research methods and experiments in the investigations of the ether drift in which the measured value is proportional, W divided by C squared, was called as the methods and experiments of the second order. Moving on. Michelson marked, the bands were very indistinct and they were difficult for increasing in customary conditions. The device was so sensitive that even the steps on the sidewalk and 100 meters from the observatory caused the complete bands vanishing. So just super interesting, I thought. In Miller's interferometer, for sensitivity increase, the optical band length in each of the shoulders reached up to 64 meters. It was gained due to applying of multiple reflections. So he used mirrors going back and forth across to make the laser travel on a longer path, which then allowed him to have a more sensitive measurement. The positive results of Miller's experiment, by virtue of their general physical significance, attracted the physicists great attention at the time. In the monographs devoted to ether drift problem and referring to 1921 to 30, are mentioned that almost everyone were concepted on the discussion of Miller's results. And the people were saying, it could have been temperature, could be pressure, it could be solar radiation, could be air streams. However, the most essential reason which made Miller contemporaries consider his experiments erratic was that in numerous consequent works, for example, there were 0 results, but major number of experiments with a 0 result bill possible to understand. Blah, 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 blah. Where is it going to get to? He paid attention. So Miller noticed that everybody that tried to do what he did, they placed them in hermetic metallic chambers. So they tried to guard the devices from the ether wind, essentially. Or at least that's what Miller's saying. Like, Miller's saying, you guys are doing it wrong. You're putting it in metal. Material medium for electromagnetic...
Wow.
Yeah. So the positive result of the experiment can be considered as experiment. So, okay. So I guess before we get into the next part, any questions?
Yeah, so just to clarify, right? Pretty much Gaelev's findings of the testing of different metals was based on what he saw the critics of Miller do way back in the day. That's how he got the idea.
Yep. He's like wondering, like, well, what's what's causing this difference? It's clearly he wanted to measure it. He saw the difference that between Miller's results and other people's results, and he's like, let's quantify this, let's measure it, and that's kind of what this whole paper is.
So they knew about this even back in the 20s, bro. They knew about Gaelev stuff 100 years ago.
Yep, dude, it's even worse than that, bro. We found a paper last night where Sagnac's basically saying he did experiments at altitude and got higher readings, and if they're going to use that, or if they're going to use a stationary ether theory to explain Airy's failure, there's going to be a conflict because they can't have a velocity change at altitude. And then what was that? A couple years later, like 10 years later, they rolled out Michelson Gale Pearson. So like they definitely knew some stuff, man. But yeah, continue on, please.
Cool. So the positive result of the experiment can be considered as experimental hypothesis confirmation of the ether existence in nature and as material medium. So this part I think is really cool. He talks about the measurement method, and he's going to describe here 4 different effects. These are the 4 different things that he's considering with these measurements. So we have the anisotropy effect. The velocity of electromagnetic waves propagation depends on radiation direction that is stipulated by the relative movement of the solar system and the ether, the medium. So he says solar system here. He knows it's not Earth rotation, but this is what they call Earth rotation. So the relative, basically, he's saying Earth rotation, quote unquote, here, what we call ether wind. Then there's the height effect. The velocity of wave propagation depends on the height above the Earth's surface. And then he goes on, actually, I would probably highlight this now because the more I've been reading into this and contemplating this next sentence is really important too. That is stipulated by the Earth's surface interaction with the viscous ether stream material medium responsible for. So there's a height effect, to leave it simple because we'll get into it more with this hydrodynamic effect in a second. There's the space effect. The velocity of wave propagation changes its value with a period per one stellar day that is stipulated by a space origin of the ether drift, the medium responsible for electromagnetic waves propagation. So thus the height of the solar system movement apex will change its value with 1 period per stellar day, as well as the Earth daily rotating. So I guess this is the daily effect he's describing here, huh? When I first read this, I thought he was just saying the distance, essentially. Moving on to the hydrodynamic effect, because this is kind of the main, I would say, one of the more important parts of this paper. The velocity of electromagnetic waves propagation depends on movement parameters of viscous gas-like ether in directing systems that is stipulated by solids in interaction with the ether stream, material medium, responsible for electromagnetic waves propagation. As it is known, the law of fluid gases in motions and their interaction with solids is learnt by hydroaerodynamics. This effect apparently should be called as the Aetherdynamics effect, with reference to ether dynamics. So, we're going to be getting into the relationship of ether and the ether wind and etheric motion with actual fluids, actual gas, actual. Just I guess we'll stick to gas in this particular experiment, but what he's describing here is that there's a relationship. The motion of gas, water, liquid, solid. That's why he goes into he starts talking about the metal and such. It's this is a very complicated relationship that's, I think, going to take a lot of studying to understand. But he's he's starting to quantify the relationship with this study. According to the investigation purpose, the measuring method should be sensitive to these effects. Now, just real quick, I'm going to get into this more in a bit. But, you start thinking about the quote-unquote Coriolis effect. You start thinking about this. You start thinking about the ether wind and all of our weather patterns. This is what's going on. This is the real driver of the weather here, in my opinion, is this ether dynamic effect. The ether flow, ether dynamics, and then hydroaerodynamics that occur as a result of that are, I think, what drive all of the weather patterns on our Earth. That's just me. Well, not just me. I think Gaelev would probably I would assume he would hint the same thing. The ether is a material medium responsible for electromagnetic waves propagation, just AKA, you shine a light, you need that wave to propagate, so it's going to go through the ether. Even if it's in a vacuum, it's going to go through the ether. The ether has properties of viscous gas. The metals have major ether dynamic resistance. Hydroaerodynamic effect is accepted as the initial position. The method of the first order based on known regularities of viscous gas medium in tubes has been proposed and realized within the optical electromagnetic waves band. So let's go to his image here real quick. So this is how he's going to start. He's going to start talking now about his testing method. So he's got this tube here, and the emitter is going, or the laser is going to go through this vacuum tube. But then you've also got this gas going this way, or maybe this way. I think it's this way, actually. And as this gas is going this way, he does the math to take into account turbulent streams of gas and laminar streams of gas. And what he's able to measure is how much of this translation of motion is going through the actual metal tube. And some of it does, but it's what he found, essentially, is that the metal tube specifically tends to block out the ether drift. But it's just a crazy concept when you think about it, because it's actually so viscous that some of it does still translate through the metal shield. And that's picked up by the interferometer with the phase shift. So moving on. Laminar stream. So yeah, here he's... I guess I should probably talk about this for a second. So the method of the first order based on known regularities of viscous gas movement in tubes has been proposed and realized. So one other thing to mention is he does it with this gas. He's blowing it actually from every direction. They end up turning it a bunch of times so that they can take the measurements to see, like, so right now the gas is going this way, but then if they turn it like perpendicular, they did it perpendicular as well, so they can measure the translation of motion going this way. And then they did it going straight into the tube, so they can measure the translation of motion going straight through. And so that way they can more precisely quantify the effects of that laminar flow. So I'm not going to read all of my highlights. Try and kind of just whiz through here, because we still haven't gotten to the pendulum. Mach's number... So yeah, he's saying here, at the requirement implementation, it's possible to neglect the gas pressure effects and consider the gas stream as the stream of incompressible fluid. Hence, the requirement is performed. The stream of gas-like ether can be considered as a stream of viscous incompressible fluid, and the use of hydrodynamics corresponding mathematical apparatus is true for ether stream analysis. So down here, they end up taking, basically what they're saying here is a lot of their math that they're using is based on fluid dynamics, which is pretty cool when you think about they're applying it to interferometer readings in a vacuum tube. The fluid stream in a tube exists only as laminar and does not depend on an extent of an exterior stream turbulence. That's highlighted in red for a reason, because like I'm saying, they're getting a direct translation of that laminar motion. So yeah, that was kind of just all getting into how they're measuring it. I think we probably should not spend too much time on the math, because I am not the best person to try and explain it. We went through it a bit with Eric the other night. Me, Alan, and Eric spent a bit of time going through it. They're using bezel functions for the shape of the sphere, or the cylinder, and then they're using a Poiseuille's parabola, which is related to, like we said again, fluid mathematics. Yeah, so this implies that a tube with the length LP, L sub P, there is the ether stream, the velocity of which changes in time. So the phase of a light wave measured on a table output should change in time according to the variation in time of the ether stream velocity. So yeah, they actually, this graph is showing that another way that they were able to have precision in their measurements is they actually start at a zero velocity of that ether stream, the fluid that they're shooting through here. And so as they crank up that speed of that fluid, they're then able to take this parabola or this chart, and they can see exactly how that laminar flow ramps up, how that's measured with the fringe shift here.
Yeah, when it gets to a specific point, they consider it reaching its maximum potential, because it's like one of those things where it's always trending towards 1, but it'll never reach 1.
Yep.
So when it gets to that 0.95 range, that's when they consider it reaching its what did you say? It's 0 point, Toby?
Yeah,
Whatever
I guess
it
so.
was.
That works. So this implies that in a tube with the length of L sub P, or we already read that, didn't we? Or did we? Yeah, we did. So I have not even finished going through the rest of this paper yet. I've skimmed it a lot, but I need to finish going through all of it still. But let's just skip down towards some of these measurement results. So these 4 experiments have been performed at various points of a globe with 3 different measuring methods: an optical interferometer of the first order, a radio interferometer of the first order, and then optical interferometers of the second order. The measuring methods action, which are applied in the above mentioned experiments based on waves propagation regularities in moving medium responsible for these waves propagation. Ether drift, so original matches original hypothesis that allows to treat the experiment results in terms of the ether drift velocity within the original hypothesis. And so I think we kind of got through at least the main idea of this paper so far. I think we're going to probably circle back to it eventually at some point. But the idea, what I wanted to talk about here was, first of all, him kind of vindicating Miller to an extent, and then also to talk about this relationship. I love this discussion about this relationship of the hydroaerodynamics and ether dynamics, because it really adds to this discussion about the Allais effect. Let me look through my notes. Yeah, so I already talked about Coriolis, quote-unquote. The rotation causing that is nonsensical. We talked about ether viscosity. So now, let's finally get to the old pendulum, huh? I didn't actually plan to bring up a pendulum example. I assume we kind of all know how it works, but maybe not. So,
hello and welcome.
Yeah,
everybody.
I don't really have a demonstration of Foucault's pendulum to show here, but I'll just try to describe it real quick. Essentially, you dangle a ball, and you let it swing back and forth on a full rotational axis. So it's not just a two-dimensional back and forth swinging, but it actually is able to do a full rotation if it wanted to. As it swings back and forth on our Earth, there is a precession that we can observe with a pendulum. And essentially, as that ball swings back and forth, it slowly spins. We really are going to have to actually pull up an animation of this. I think that's going to be best.
Yeah.
Is this a precessing pendulum? No. Is this a precessing pendulum? Dude, just give me a simple pendulum precession.
You just need the pattern.
Yeah, basically.
Dude, I was looking for one the other day. Good luck.
Here's one.
Let's see if I
Hand
can
pendulum.
find
This
it.
is kind of cool. This gets the idea across at least. So let me stop sharing and start sharing. So you can kind of see the shape it's making here, which kind of helps show how it processes. This one's not really processing perfectly. Typically, it'd be more of a, well, here it's kind of starting to do it. But you see how it's changing directions here, right? It started going this way, and now it's going this way. And it's
Yeah.
they try to say that the Earth rotation causes these pendulums to precess. And what they actually say, I'll go back to sharing my my PDFs.
It's like a pretzel pattern, dude.
Yeah, I mean, it's actually like when they process perfectly, it's a bit more of like little bit more, not really spirography, but a little bit more like has a little bit more symmetry to it. But let's see here. Where is toilets? Here we go. And then let me share my screen.
Ideally, it would pass right through the center each time, right?
Well, yeah, without any precession, it would just stay straight, and then with precession, it would slowly deviate. So real quick, sharing my screen here with this gyroscopic rotation thing. So this is the assumed Earth gyroscopic rotation. You know, they talk about, thanks, Bob, 15 degrees per hour Earth rotation. This assumes that. This is what their model would have to have. Now, me and Alan have been starting to look for evidence of this. This is how the pendulum should precess. This is how the gyroscope should pick up the circle here. And if you're wondering why we spent so much time talking about interferometers just so we could finally talk about pendulums and the Allais effect, it's because they claim the exact same thing causes both of those. It's the rotation of the Earth causes the pendulum to process. They claim it's the rotation of the Earth that causes the ether wind measurements. I'm going to say here the pendulum precession and the interferometer are both being caused by ether wind. Now this here, a lot of people accept this as truth, that this is exactly what happens, and I think this was incepted cleverly. I don't know if you guys have heard of the idea, if any of you remember when we were kids, and they told us that toilets flush in opposite directions in the northern hemisphere than they do in the southern hemisphere. And then, I don't know if you guys heard, but 10 years ago or so, it became common knowledge that that was not true at all. And that was just a made up thing that we were all told, and that it's not quite so straightforward whatsoever. And so people grew up with that belief. They thought, oh yeah, Earth's rotating because toilets flush in the opposite direction in the southern hemisphere, which was shown here. That's how that would work, because you'd get this direction here, and then you'd get this direction here, from this divergence from the equator. And yeah, so that came out that's not even true. And then because we were incepted with this idea that toilets flush the opposite direction in the northern and southern hemisphere, when you're told, oh, well, pendulums do the same thing. They process opposite direction in the northern and southern hemisphere. You just thought, well, of course, that's what toilets do. So, of course, that's what the pendulum does. And then when you're told, yeah, well, Bob's gyroscope, it should go 15 degrees per hour up here and 15 degrees per hour down here, no matter where you are, latitude, no matter where you are, altitude, you thought, well, of course, right? And so that's how we get this image here, where it's like we just know this has to be what's happening, even though we've never definitively measured it. It's an insanely complicated thing to try and measure, and to try and make assertions that it would be uniform like this around the globe without those precision measurements is quite an assertion. Yeah, so moving on. So toilets, Allais effect. Yeah, so along comes Allais, 1954. Here is his paper. I have not translated it. I'm planning to do that still, but let me pull this back up. But just to really quick read from, I'm just going to read what ChatGPT has to say about Allais. Allais effect refers to the acclaimed anomalous behavior of pendulums or gravimeters, which is said to occur during a solar eclipse. It was first reported by the French physicist Maurice Allais, who observed it during the solar eclipse of June 30th, 1954. Allais conducted his experiments in Paris, France. He noticed that during the eclipse, the plane of oscillation of a Foucault pendulum exhibited unexplained irregularities. This phenomenon sparked interest and controversy in the scientific community, leading to various attempts to replicate and explain the observations. This is ChatGPT talking, so the Allais effect remains a topic of debate, with some attributing the observed the observed anomalies to local environmental factors or experimental errors, while others suggest it may indicate new physics beyond the standard model of gravity. Despite numerous experiments conducted during subsequent solar eclipses, a definitive explanation or repeatable demonstration of the Allais effect has yet to be achieved. Okay, let's look into that, ChatGPT? Usually you've got some good gravy, but I don't know if I trust you on this one, bud. So Allais ran into it in 1954. Let's look at these guys in when was this? 2006. A confirmation of the Allais and Yeverdon-Rousseau-Antonescu effects, which is another effect I still need to dig into here because it's very correlated in with this Allais effect. Happens during eclipses. Confirm once again the existence of the Allais effect, change of speed of rotation of plane of oscillation of a pendulum during an eclipse, and Yeverdon-Rousseau-Antonescu effect, so which is the change of period of oscillation of a pendulum during an eclipse. Although the annular solar eclipse from 22nd of September 2006 was not visible from Romania, a gravitational perturbation was detected with a sensitive paraconical pendulum. And then here, first we use the method of JRA, developed and utilized by Allais, and we have determined that the experimental value of the period of oscillation of the pendulum, and after the maximum, assumed to correspond to the local gravitational acceleration. Although the annular solar eclipse from the 22nd of September 2006 was not visible from Romania, a gravitational perturbation was detected with a sensitive paraconical pendulum. This shows us that the gravitational perturbations who appear along an eclipse in a zone of anti-eclipse are similarly with the tide produced by the moon when are at anti-meridian. So this is just another example of someone measuring it, even though you will hear people say that no one's measured it or it's been refuted. And on that note, before we get to the, I would say the real home run on this, let's pull up one of these refutations. Let me see here. Where are you? Here we go. So, searching the Allais effect during a total sun eclipse of 11th of July 2010, they say they found no evidence within the measurement error of the Allais effect. Now, I didn't even make it too far into this paper because look at this. It has a feedback amplifier that keeps the continuous oscillation of the pendulum at 1 degree's amplitude. So these things, obviously, they can't swing forever. They have to, they run out of momentum, and then they would have to be restarted again. It's not so easy to start a pendulum. It's actually quite complicated because you have to induce no directionality when you start it. But in any case, it also has an electromagnetic brake which keeps the elliptic trajectory in acceptable values. What are we even doing then? And by the way, just in case you thought maybe they would account for this later in the paper, only time it's mentioned. So they're just breaking the whole thing. You're not going to detect it when you have a break that keeps it in your acceptable values. This is such a stupid paper. And if anyone were ever to try to use this to debunk, quote unquote, the Allais effect, the fact that this even got published is so sad in my opinion. In any case, now let's actually get to the home run where we can actually show, these people that are going to say, well, I don't care about this, Allais was full of it, and these guys are just down in, Romania. I don't trust these Romanians. Okay, well then maybe do you trust Harvard? Let's pull that up. 1970 solar eclipse as seen, quote unquote. They can't even like admit what they're measuring by a torsion pendulum. The regularities occurring before the start of the eclipse might be considered accidental, except that data taken 2 weeks later at the same hour of the day show corresponding humps, an indication, by the way, that the observations are reproducible. The maxima and minima may indicate a kind of gravitational fine structure which is responsible even when the positions of the sun and the moon relative to the Earth are quite different. So this is talking about a daily irregularity, which is insane already on its face. Like, how does Earth rotation do that? This apparent wave-like structure has been observed over the course of many years at our Harvard laboratory. It cannot be predicted on the basis of classical gravitational theory, nor has it been observed in the quasi-stationary experiments underlying the theory. Furthermore, the actual values of these observed times are greater at the later date. On the occasion of the sun and the moon were at the opposite sides of the Earth, whereas during the eclipse they were in conjunction on the same side. This difference in relative position might well explain an increase in the observed times. These times are known to increase with increase in tension on the wire and therefore with gravitational attraction. Thus, the moon pulling in the same direction as the Earth could be the expected increase of the. They're just trying to explain it here, but there's no good explanation. They're saying that they're trying to correlate it with a 5% total weight increase of somehow here. But here's the real home run. Results of this order of magnitude have been consistently observed in Harvard over a period of 17 years. The greatest possible variation in G computed according to the oldest theories for a given site on the Earth is 0.00016 centimeters per second squared, or 1.6 times 10 to the negative 5%. So that our results are about 10 to the fifth times as great. Where the maximum average deviation of our results is about 2.5 times 10 to the negative 2%. It is further to be noted that the greatest change occurs between the onset of the eclipse and its midpoint. This agrees qualitatively with the work of Allais, which a paraconical pendulum where the change of azimuth increased substantially. The change of azimuth increased substantially in the first half of the eclipse. So I think that's literally the effect I have not actually fully ascertained at this point, to be completely honest with you. Sometimes I hear it described as a perpendicular motion, but here they're describing essentially that, and I actually saw a YouTube video of this too, that essentially the during the eclipse, the pendulum actually goes higher. There's a change in azimuth, which actually corresponds with what he's saying here with the loss in the 5% of total weight. So something that would correspond with a 5% weight loss causes the pendulum to go even higher in its azimuth, to swing up even higher than it normally would.
Question.
Yes.
Well, two questions. All right. So number one, you're telling me that 10 to the fifth margin greater. So they're saying that this effect would be 100,000 times more powerful than that predicted by gravitation under the classical model.
Yeah, that's my understanding as well.
And yeah, okay. And number two, so it's obviously electrostatic. And number two, wouldn't that mean that what's happening is this is like observing ether drift affecting the precession of an analog medium, such as shows that, like with the metal experiment around the interferometer as a shield, that the interactivity of a solid material with the ether can cause a precession?
Yeah, yeah, that's exactly why I thought this was perfect to tie in with all the Gaelev stuff.
So the inverse of it would be that what they would call a gravitational field, what actually is happening is, as we would say, it's electrostatic in nature, but these bodies are electrostatic in nature, and because there's larger number or larger mass of bodies that have an electrostatic effect in a region, when they're over that same region together at the same time, it's an increased electrostatic effect, which causes an increase in the rate of precession. Local precession.
I'm not totally sure I follow. I actually... What's that?
Increases. The precession increases during the eclipse event, right?
I actually don't know. I think it would actually, I guess you probably would get a precession increase, but like I said, the real thing that's happening is that the pendulum ball is going higher on the azimuth. It's swinging even higher than it does before the eclipse starts.
Yeah, so the same the same wavelength but a different amplitude, basically.
Yeah, it could be something like that. Yeah.
But gains energy goes higher.
Yes, it goes higher, which would correspond goes so much higher it would have to correspond with a 5% gravity loss.
Okay, so it wasn't the precession pattern. Sorry, it was the strength, right? The energy
Oh,
in the precession.
yeah. Yo, sorry. Brian says that azimuth is speaking to direction, not height of the
Oh,
swing.
thank you. Okay.
Yeah,
Oh,
so
it is direction.
it's changing direction corresponding to a 5% shift in gravitational pull.
So it's what I said the first time. It would be that the local electromagnetic effect from the heavenly bodies is causing an increased speed of local precession of
Yeah,
the
you
ether.
guys are right. My bad. You totally had that right, Jesus.
Dang, bro. So it's like the inverse of gravity, bro.
Yeah. So now that we've gone through all that, let's go on to some fun eclipse effects. So let's start with grease here, just to kind of grease the wheels. Where are you?
Real quick,
Yeah.
I don't know if you saw in the live chat, but I did find a couple good pendulum videos for you.
Oh,
next
cool.
time.
All right, yeah. Before we go any further, let's watch one of those. That's probably a good idea.
Pendulum video break.
This is pretty sick. I'm not gonna lie. Like, wow. So we can detect ether via analog mediums, bro. That is like
that are in motion, right? So
Yeah.
like a
analog medium. Yeah.
Yeah. Wait till we get into Marinov, though. You're gonna like
Oh.
Marinov. You're gonna like
This
it
is
a
like
lot.
a
Needs to be
parallel of the
autonomous.
flywheel battery. You know the flywheel battery, the kinetic analog energy battery. It's like a perpetual energy machine acting as a battery. It's not perpetual, right? It has a loss, but anyways, it's just like a parallel to that because the ether is acting on an analog medium here. It's like there's analog forms of pretty much every kind of wave-based technology. To be
This
honest,
is perfect. Good find, Quinn. This is a precessing pendulum.
Yeah, you were like, I can't find one. I'm like, I remember getting one of these papers from a place called the Science Place in Dallas, Texas, when I was little, because it was like a pendulum drawing that you can get.
Yeah. So the one thing here is you can see it's actually slowing down. But a lot of these pendulums that they use have they have an electromagnetic motor, essentially. Not really a motor, it's kept in motion through electromagnetism. Yeah. Cool. So yeah, I think that's illustrating it pretty well. Now, typically the reason that this is getting this like spiraling in motion is because it's slowing down in speed. Usually it would be more of it would look more like a star, because it would keep the same go out to the same distances. I guess I can try and see if any of these other videos show it a little bit.
Yeah, sorry I'm late. I'm not home yet. I had to fucking do a job, but
Oh, you're good. No worries. No worries, Biasticles. So yeah, there we go. We got processing. I think we get it now. So let me go ahead and go back to sharing my PDFs.
I wrote that, bro. Reminds me of something. It's almost like it reminds me of the spirographs of the planets.
It's like the vortex, as y'all are always talking about.
Yeah, the toroid.
So yeah, this was 2006 on March 29th. They were measuring meteorological variables in Greece. And actually, there are an awful lot of papers about this. It's pretty interesting. They integrated micrometeorological measurements. Surface wind decreased in most sites as a result of the cooling and stabilization of the atmospheric boundary layer. Every time they're asserting causes here, I'd be a little bit skeptical, because the more I dig into this, the more this is not quite so substantiated. Strong anomalies not associated with a dynamic response. Not associated with a dynamic response, so basically not with no dynamic explanation. Were simulated over land, especially in surface air temperature. The simulated temperature drop pattern was consistent with the observations. So basically, it's funny how they put this. It's like they're specifically trying to obfuscate the fact that this was highly anomalous. They used an anomalous model. They simulated They simulated an anomaly, and then they said the anomaly matched what they observed. But yeah, so that's that paper, and then just to kind of get going about that, let's now go into this other paper here. Surface pressure fluctuations produced by the total solar eclipse of the 1st of August 2008. This one is pretty interesting. Now you have to we're going to have to step into their fantasy land to read this one, because they have this thing they like to talk about of gravity waves. Since the eclipse shadow, this is like me and Alan were really blown away when we read this last night. So, since the eclipse shadow travels within the atmosphere at supersonic velocity, this cooling generates a planetary scale bow wave of internal gravity waves. I don't know if that makes sense to anybody. If it does, you should make sure you're thinking all right.
You don't think it makes sense?
Well, they're saying that a shadow is traveling at supersonic velocity and causing gravity waves. Now, the thing that you realize, what makes a little bit more sense when you realize that what they're actually doing, what they think of as gravity waves, is infrasound. So surface atmospheric pressure fluctuations produced by the passage on the August 28th solar eclipse. They use a temporary network of microbarographs and infrasound stations, essentially the same thing, but the infrasound stations, let's actually watch that. That's a pretty cool video. So just to get the idea of how they're measuring this.
Dude, meteorological professionals use this concept too. That's crazy.
Yeah, so you're going to like this video. This is pretty interesting.
I mean, the weather people are co-opted. Is that what you're telling me? Or do they know?
Well, they just, this stuff's not so easy to explain, I think. And I think that, we just accept the explanations that we're given, and, we're still, I think they just kind of accept what they're given. So
the white dots that we see here are 60 infrasound stations. They monitor the globe for atmospheric or shallow underground nuclear explosions. Such explosions create infrasound waves, low-frequency waves inaudible to the human ear. This event here could be a volcanic eruption, a storm or an explosion, all creating infrasound waves that are registered by our infrasound stations. Such a station consists of several elements. This one has 8. The distance between the elements can vary from 1 to 3 kilometers. This is the best setup for trying to identify and locate the source of the infrasound waves. Each array element includes pipe structures to reduce the surrounding noise and amplify the signals. Filters at the end of these pipes prevent animals and dirt from entering them. When acoustic waves reach an infrasound station, the waves travel through these pipes to an infrasound sensor called a microbarometer. This is located in a vault at the center of each array element. It transforms the infrasound waves into electrical impulses. Each sensor transmits the signals to a central recording facility by radio or by fiber optics. This setup uses radio connections. At the facility, computers record the signals and prepare them for data transmission via satellite link to the CTBTO in Vienna. Everything proceeds automatically. And here we see the entire process again. Infrasound waves arrive at the station, are registered by the individual sensors, and transmitted as electrical signals via a radio connection to the central facility, and from there by satellite to the CTBTO in Vienna. There the data are analyzed to clarify the nature of the event.
You'll CTBTO. So yeah, they've got a global system of these microbarometers, and they use that to detect infrasound waves. Now, infrasound is basically below the audible spectrum. It's like, you could call it quote-unquote lower. So that's what they're picking up.
Below 20 hertz.
Yes, sir. Detectable pressure fluctuations at the ground surface. Tropospheric cooling is likely to be the predominant source, they say, and highly perturbed by atmospheric tides and the meteorological phenomena. The pressure fluctuations produced by the latter synoptic disturbances are characterized and removed from the recorded signals. So they're trying to, specifically look for the effect of the eclipse. Low-frequency gravity waves starting just after the passage of the eclipse are then brought to light as at most measurement sites. strongly suggests that these waves are produced by the passage of the solar eclipse. The thermal forcing produced by the daily heating of these absorption regions generates large-scale gravity waves. At subharmonic periods, these waves, called atmospheric solar tides, cause regular pressure oscillations. So basically what I'm gathering from this paper is essentially there's like some kind of massive pressure mediation event happening. Now, maybe you could explain this purely with the shadow that's being cast. Maybe. But I think it's a bit... it's certainly an interesting thing to study. They use the same stratospheric thermal cooling term in the background atmospheric conditions. They presented stationary solutions related to the middle.
Question.
Yes, sir.
So they're basically doing the same thing that they did with Miller when they criticized him, as they tried to like dismiss it and say it was temperature inversions, right? Changes in temperature, which is like what the tropospheric cooling factor thing is. There's going to be a variation in temperature as well as the shadow. So what they should do is repeat the same type of experiments at altitude, right, at like a mountain station, and then compare and see if you get the same reproducible effect that Miller did, or the same proportional shift and increase. I predict they would.
Yeah, that's an interesting thought. And just real quick, they say like this type of stuff ultrasound picks up is generally like thunder, earthquakes, explosions. They say, it's funny, ChatGPT told us last night that it picks up meteorites. And so we went to go look into that, and we found one example where they picked it up. They picked up a quote-unquote meteorite, and it's this here. It's this Russian fireball, largest ever detected by CTBO's infrasound sensors. This is the one example they have of that, so if anyone's ever going to try and tell you that they used infrasound to detect meteorites, I would just be highly skeptical of what they're actually detecting. Yeah,
Wow.
so that's all of that. Now let's get into my favorite paper of this whole thing, probably. Influence of solar eclipse on seawater. So eclipse-induced changes in solar radiation could generate gravity waves. Back to the old gravity waves. Reduction in the concentration of ozone layer in the stratosphere. So they're saying, oh my goodness. They say that the gravity waves from the moon's shadow result in a reduction of the concentration of the ozone layer in the stratosphere. And solar eclipse phenomenon affects the pH value of seawater due to the shorter wavelength radiations received on the surface of the Earth. Let me actually zoom in here.
Man, eclipses are crazy.
Right.
Wow.
No. I mean, it's cool to learn about this from this angle, because I mean, I have experience with eclipses from like an astrological view, and and then like very superficial scientific, but it's cool to hear like this like deep dive or a deeper dive into this element. But go. Yeah.
Cool. Yeah, I'm glad to
It's
hear that.
amazing.
Thanks. Cool. Yeah, so the reduction is around 20 and 40% of the difference between ordinary water and seawater in annular eclipses, respectively. So
40% difference in pH shift. Wow.
Fucking wild.
So yeah, so they say here the eclipse rare phenomenon gives us opportunity to investigate how the ionizing radiations react to the material surface of the Earth due to the fast solar radiation changes. Now, this whole thing, man, is insane, because I just like straight up asked ChatGPT, like, okay, so what they're saying here, they're inferring this gamma radiation difference. Maybe I'm getting a little too. Let me just keep going through the paper. So talk about ionizing radiations react to the material surface of the Earth due to the fast solar radiation changes. The disturbance of the heat balance along the supersonic travel of the trajectory of the moon's shadow could generate eclipse-induced gravity waves, which result in a reduction in the concentration of ozone layer in the stratosphere. So they're talking about the ozone. They're saying that the eclipse shadow causes the ozone layer to reduce. And then the radiations in shorter wavelengths are generally influenced more by the eclipse. And at large eclipse percentages, it slowly decreases as the eclipse approaches maximum compared to that of the shorter wavelengths. You know, I guess I actually should have pulled this paper up, and I didn't. Maybe we can do that later on. Compared to that of the longer wavelengths. Hence, one can expect shorter wavelength radiations during partial eclipse, which is less studied. Yeah. Because what I tried to ask ChatGPT last night, and I'll just read it real quick. I was just wondering, like, because they're coming to this idea of gamma radiation, and at the end, when they get to their conclusion, their proposed explanation, they try to invoke a couple of things. They try to invoke sea life, and they try to invoke gamma radiation. But I just asked real quick, ChatGPT, what's up with chat radiation during eclipses? When does the change in gamma radiation begin? And then says, during a solar eclipse, there are notable changes in the Earth's upper atmosphere, specifically in the ionosphere, which can impact gamma radiation. The ionosphere is significantly affected by solar radiation and is a primary source of ionization. During a solar eclipse, the reduction in solar radiation leads to a decrease in ionization, particularly in the region of the ionosphere at an altitude of about 37 to 56 miles. This decrease in ionization results in a temporary drop in the density of electrons in the ionosphere. So, where is it that I just get to the point here? Has anyone ever measured gamma radiation during eclipse? So in 2020 in India, they saw a 88.3% of the solar disk was eclipsed, and 2 sodium iodide NaL scintillation detectors were employed, and flux was recorded. Flux was measured in India as well in 2010.
I'm going to give you the whole load today.
I'm sorry. That's my entrance.
Oh, you're good. And then in 1995, so those two, all they reported, and those other two, I didn't actually look at the actual sources, but it just says variation. And then this third one, in 1995, they say that there was actually a decrease in the cosmic gamma rays in the energy region of 300 to 3000 keV during eclipse. This decrease was interpreted as due to a process of cooling of the upper atmosphere. So, I don't know, I probably should look into these specific sources about this, but in any case, they are going to be trying to invoke this gamma radiation or these gamma rays at some point here, and they say it's less studied. India had a total solar eclipse on. So now we're going to get to the actual study here. India had a total solar eclipse on the 22nd of July 2009, which was visible over the central India, and a partial eclipse in the southern part. Annular eclipse on the 15th of January 2010, and this paper focuses the study on the conducted seawater during these events. So there was one in 2009, one in 2010, and the one in 2009 was the largest total solar eclipse in the 21st century, and then the one in 2010 was the longest annular solar eclipse of the millennium, and the longest until the 23rd of December 3043. The eclipse started in the Central African Republic, traversed Cameroon, DR Congo, and Uganda, passed through Nairobi, Kenya, and passed over the Indian Ocean, where it reached its greatest visibility magnitude of 0.9190. At approximately 1320 IST, the annual solar eclipse entered India at Thiruvananthapuram and then at Rameswaram. The sky was clear throughout the event, and hence the eclipse maximum from 1324 to 1329, so 5 minutes long, gave it a dark effect of decrease in light intensity. And then he mentions here, Gaelev et al. Observed a continuous decrease in wind speed without any significant change in direction during the solar eclipse of 1999. Yeah, there's a few papers about changes in wind directions and changes in wind speeds. And change in the pressure gradient force during the eclipse. So, moving on, the seawater from the Bay of Bengal, the eastern coast of India, was subjected to the study to find the influence of solar radiation on the pH value. Now, solar radiation, they don't really, they're taking a leap there to say that it's the solar radiation that even causes this. But on the pH value on the exposed conditions, since major part of the Earth is covered by sea, pH is a measure of the acidity and alkalinity in a substance and is one of the stable measurements in seawater. Ocean water has an excellent buffering system with the interaction of carbon dioxide and water, so that it is generally always at a pH of 7.5 to 8.5. And if anyone's ever kept a saltwater tank, you are very familiar with those numbers. we were able to detect the abrupt change of solar radiation and its effect on seawater. BS. And we'll get into why. During the annular eclipse of the 15th of January 2010, the pH value of seawater was recorded well before the beginning of the eclipse at 30 seconds resolution. And now we get to the results. A significant decrease in the pH value of seawater is recorded on the total solar eclipse day, 22nd of July 2009, when exposed to solar radiation during the eclipse period. I mean, I guess, yeah, when exposed to solar radiation, sure. Which reveals an increase in hydrogen ion activity in seawater. Considerable reduction, I mean, even that causality I would be a little skeptical of. It might be what's going on. Considerable reduction of 20% of the difference between pH value of the normal seawater. The pH value started decreasing from its original value an hour before the eclipse and reached its maximum reduction when the moon's umbral shadow was on the solar disk 45%. And when the eclipse percentage was maximum, the decrease in pH value is minimum. So, before the eclipse even starts, here's the eclipse.
Wait.
Yeah, you heard it right. You have a question?
Wait. Yeah. Hold on a second. So the pH value started decreasing from its original value an hour before the eclipse and reached its maximum reduction when the moon's umbral shadow on the solar disk was 45%.
Yep.
And when the eclipse percentage was maximum, the decrease in pH value was minimum. Another decrease in pH value was recorded again when the solar disk was covered around 40%.
Whoa.
During the process.
Dude. I skipped that last night.
So, sorry.
You're good.
Sure you were done with your.
No, you're good. Go ahead.
So, first thing I was like thinking, I was like, dude, I bet this is like an Indian paper because, like, you know, all the Vedic Indians, like, they love eclipses. I don't know, they highly revere eclipses. But
cool.
when eclipses happen, so there's the declination of the moon where the moon is like going up and down in it has like a waveform. But when it approaches eclipses, it slows down, it becomes stationary. If that makes sense.
Toby?
What's that?
Can
You may scroll down? Yeah, sure.
You're saying the moon has a very fine oscillation and the oscillation stops during an eclipse?
It gets slower as the eclipse approaches.
Increases?
Yes.
And at full eclipse, like zenith, maximum blackout, it's not moving?
There we go. That's
I gotta double check, but I'm gonna say yes.
That's what I wanted to see.
Approaching to the eclipse, like it's a bigger period. It's not just confined to like the eclipse, like the eclipse event, but it may be within like a day. I have to double check. But it is like the closer to the eclipse, the slower the moon is oscillating, coming to a standstill.
So wait, let's look at this little graph here. Let's see this. So on the left's pH, and then the bottom is the timeline, right?
Yep, and then you've got a normal day, and then you've got eclipse day.
Wait a second. Normal day. Even normal day is interesting.
Yeah, right? Yeah, so pH does drop at night, and the reason that happens is, or at least what they say, I mean, at this point, I'm highly skeptical of all their explanations, but they say that's due to, and I'm sure there is probably some truth to it, that it's due to microbiological activity, essentially, or biological activity of animals going to sleep, and, I mean, they get into it later on.
It shows it's increasing.
Yeah, it goes up as the day goes on, essentially, right? Or wait, no, this is 5:30.
Yeah. As nighttime's approaching, it goes up and higher.
Did they say animals going to sleep has something to do with pH decrease?
Increase.
All the algae and plant life in the sea.
It's increasing.
As well.
Normally.
Yeah, it's increasing, becoming more alkaline.
Yeah, but look at the eclipse.
Yeah.
Oh.
The eclipse is actually decreasing the alkalinity.
Yeah.
Oh, it's decreasing the alkalinity.
It's like a following up and down. Yeah, it's interesting.
So
Yeah,
it
yeah.
becomes more acidic.
It's more acidic
Okay.
around, so it's not too much.
But
Doesn't
also
look
you
like
can notice
too
here
much.
it starts at a lower position here, right? Like this is coming into it, and it had come down. Like it's relatively lower even going into the eclipse.
It's not even. That's not that much lower.
No, but you know you also have to consider you're talking about what they set up here. It has a
That's what I want to know. Like, okay, that doesn't even make sense. It says considerable reduction, 20%, right there, top right, yeah, of normal water and seawater.
where at?
Right down more, right there, on the right there. Okay, so the pH value. It says the change in pH value against time is plotted in Figure 1, which reveals a considerable reduction of 20% of the difference between the pH value of normal water and seawater. Then it says the pH value started decreasing from its original value an hour before the eclipse and reached its maximal reduction when the moon shot. So go back down. Let me see. Let me see what that looks like.
So yeah, it's already at its minimum value an hour before the eclipse. They're showing here.
So that's an hour before the eclipse. Because what time was the eclipse?
Right here, total maximum.
The total maximum right there?
Yeah.
Now look at that.
And then here's the 40%
Right.
when it's waning back off. Yeah.
What's up with that?
Isn't that crazy?
That's the weird. See, that's the weird part. Is those big drops after the eclipse.
Well, but we're going into it at a lower baseline too.
Yeah. Not too much lower, but
Biastically, you know what's crazy? If that's the case, it would probably happen in a person just like it would happen in seawater.
that's what I was saying.
Yeah,
Yeah.
exactly. Yeah.
So
when
that
we
means
first
you
were
want to drink
talking about
alkaline
it-
water? I mean, is that what that means? You want to increase like
Well-
the salt in your body?
well,
Because
bas-
electric affinity?
Eclipses make you
Traditionally,
sick.
you're supposed to fast during eclipses.
that makes
um,
sense. And you know why? What
No,
does
tell me.
fasting do?
Lowers your
Increases
pH.
alkalinity.
It detoxes you.
Oh, right,
and
right.
So it's easier to keep a higher alkalinity. So, that would
So
make
I'm just
sense.
gonna move forward
going.
here, get through
Yeah.
this paper, and then we're almost done. During the partial solar eclipse of October 1995, we have detected huge gamma counts at the eclipse maximum by gamma ray spectrometric experiments with NAI scintillator. So that actually contradicts what I had read from ChatGPT earlier. But interesting. So yeah, that's them going back to them saying that the ionosphere, like the moon shadow, causes the ionosphere to break open, and then because of that, we're able to get more gamma rays. Reduction in ozone concentration is formed because of gravity waves due to the change in the pressure gradient force. The ozone depressures allows so this is them. Yeah, their summary and conclusion allows ionizing radiation. Ionizing radiation during the process gamma rays is less studied. Here we report that gamma rays are reaching the Earth's surface during eclipse since the pH value of seawater is reduced when exposed to solar radiation because gamma radiation reduces the pH value of water. So our results are the first one reported about the influence of gamma rays when during the solar eclipse of pH value of seawater. The results discussed will probe a gateway into a new approach of the behavioral studies of marine organisms. So they're like kind of still hinting here about it being related to marine organisms in the context of salinity or pH value during eclipse period, and may add an additional parameter of the geophysical studies of polar region. Now, this whole thing is really weird because they're trying to say that the gamma rays are what's causing this. And now, actually, we did find the paper that they reference here, this one here about the irradiation of drinking water, and I can pull it up here real quick. Where are you? Here we go. So I guess I didn't highlight, which is annoying. It was not actually the main point of this paper, but they did note it on this part right here, I think. No. Here we go. There it is. Let me zoom in. So yeah, the absorbed dose of the KGY, which is the gamma radiation quantifier. So yeah, you can see as that goes up, the pH does come down. Interesting. Yeah, this paper was Zhao Bingao, Guo, Zhang Zhang, Qin Hui Gu, Deng Yong Tang, and that was in China. Yeah. In any
Dude, I wish
case,
I had 2 first names.
the thing that's odd about this is the timing, right? They're saying that the gamma rays are causing it, but if the gamma rays are causing it, then what's the cause of the gamma rays? Well, they say that it's caused by the ionizing radiations reached. But then if the ionizing radiations and if it's the
If it's
influence
solar
of the
radiation,
if it's the influence of the moon shadow that's causing the gravity waves that's then causing the ionosphere to part and allow the gamma radiation in, then why did the pH start dropping? Why was it lower already before we even get to the eclipse? Like, it doesn't make any sense.
what would they say? Like, what would they say? The gamma radiation travels faster, or something like? No, it doesn't even make sense because they would have to part the ionosphere clouds, or rather the ionic clouds.
Is the gamma radiation, is it coming from the sun, or is it just coming through space?
They say solar radiation.
Right. So before I knew anything, when eclipses would happen and I was like observing solar weather, I thought it was kind of interesting where it's like the moon is interfering with like the solar weather coming to Earth, and so it's kind of like a disturbance. But I could just imagine like the 3-dimensional weather it creates when it is in front of the sun's weather, and that's coming at us. But
I don't know.
yeah,
I see it as some kind of the sun and the moon create some kind of field polarity within the toroidal vortex that we exist within. The ether is flowing at like insanely fast velocities, and it's in that whirlwind motion while it's also in that toroidal motion. And what we see as the sun and the moon and the stars are actually specific points within those intersecting motions. And as those things process and move above us, there's constant pressures, counter space and spatial interactions that are occurring as a result of that. And as the sun and the moon, which are essentially the pole and antipole of the whole system, I think as they line up, there is a massive pressure mediation event that occurs. And I think that's what's causing a lot of these phenomena. I think that's why the pendulums go crazy. I really, really want to see some interferometer measurements that are not from LIGO or some crap done during an eclipse. And yeah, that's essentially everything I have on this.
that's awesome. It freaking blows my mind. I just love it.
I thought it was so cool to like really just see like quantify the Allais effect, like see all the people trying to debunk it and stuff, and it's like clearly this is a hidden thing. Alan, should we jump into Marinov real quick before we get to going off on anything else?
Yeah, let's cover Marinov real quick because that was super interesting, and then the ending as well is, very tragic.
Yeah, you want to take over for that one?
Yeah.
Or you know what? I can pull the paper up if you want to read.
Yeah, okay.
Because I have
Fuck is
my
Marinov?
highlights from last night.
Oh, perfect. Yeah, cool.
What's Marinov?
Marinov is a Russian gentleman who, one second, got it gone.
Actually, I can read it if you want. I can just read through my highlights.
Can I see the title again of that? What's the title?
But actually, I need to step away for just a second. So if you guys want to start reading, I'll be right back.
All right, interesting.
Okay, yeah, so back history here. Similarly to how Wang in 2003 and 4 figured out that he could use interferometry to measure linear motion, this guy figured out that he could come up with a setup to measure linear motion through absolute space as well. So and this was in the 80s. So we're going to get into his situation and the outcome of that that transpired. As soon as Toby gets back here. So keep in mind, this was in like peak Russian, Soviet Union, craziness or whatever. So what they end up doing to this guy for questioning relativity and questioning authorities, they what do they do? What do you do when you put someone in an insane asylum? You commit them or whatever. They committed this guy.
They committed Stefan Marinov.
Yeah. Yeah, they committed him over it. Dude, this paper is awesome. This dude's a legend.
What?
How do you get? Why? Never mind. I'm sure you'll get into it.
Yeah. So questioning Einstein would get you they would use that as justification to throw you in mental institutions. So that's actually cited from like a separate story, but in this it's related because they do it to him, but he also was questioning like the government or whatever, kind of pushing back on them. So you could make the argument that it was about that and lesser extent of the relativity stuff. But I do have a book where that's cited, where they specifically are doing that, taking people to get lobotomized because they don't believe relativity. Yeah. Yo, welcome back. I just gave the history of Marinov and the all that.
Y'all need to post both these papers. I'm just saying, bro.
U.S. as well.
Oh well.
Yo, I can drop everything that I got from. I drop all the stuff I presented here.
Well, this
that would be great.
Is that in your EndNote library?
This is a new one. You'll have to add this one in manually.
Oh, you fucker.
I know, dude. Every time I add a new paper, I'll have to re-upload it.
While we're waiting.
Does it detect duplicates?
No.
Dang. Name conflicts, though.
Hey, I need to go smoke this for this paper. 37%. Wish me luck.
GL.
All right.
Man.
So yeah. Whoops. Pull that back up. Here we go.
Man. You know what that tells me? If a person's alkalinity goes up, meaning there's an electrostatic action at a distance relationship between a person, a human, during an eclipse event, and that increases your alkalinity, that would mean that you'd want to, make yourself, in essence, more receptive to the frequencies that are being given off by the eclipse event.
Yeah.
That would be the intuitive thing to do.
Yeah, traditionally, like whatever, so from an astrological point of view, whatever happened, eclipses will like supercharge everything that's going on. So whatever you do will be supercharged. So if you want to practice purity and like you fast, like whatever actions you do will be amplified. But if you also practice degeneracy, then the degeneracy is also amplified, which is, anyway, it's just interesting to hear about it from like a contemporary science perspective, because I don't know, it's like cross training with like.
Are you suggesting effects on human behavior by solar eclipse and astrological events?
Oh, I thought that's like common knowledge.
Well, check it out. Even if it's at the very least like someone looking up like, oh fuck, the sun's black, that affects my behavior for the day. You know
Yeah, I don't know how much you want to talk about this.
I'm just kidding. But go ahead.
No, it's. I'll talk. Okay. I'll say something. So last year, they overturned Roe versus Wade, right? And so the eclipse the eclipse season last year happened in a star that deals with like reproduction and like. So it was interesting that like the beginning of that eclipse season, they presented they're going to overturn Roe versus Wade, and I thought it was crazy. I was like, no way they're actually going to do that. It's all a conspiracy. And then at the end of the eclipse season, they finalized it. And so, there's always like themes to like eclipses, and it's just interesting.
Yeah, that is interesting.
What's
that
next
is
year's eclipse?
because they do that. But let's bang this out real quick, and then
Yeah,
we'll
yeah,
get
yeah,
back
go for it.
onto that stuff. So.
Ready.
I
Get
can go ahead
distracted.
and breeze through here if we want to just go through my highlights. Does that sound good?
Yeah.
Yep.
Cool. So this time, the following definite figures for the Earth's absolute velocity have been obtained. Magnitude 360 plus or minus 40 kilometers per second, with equatorial coordinates of the apex of epsilon equals negative 24 degrees plus or minus 7 degrees. Alpha equals 12.5 hours plus or minus 1 hour, February 1984. Did you explain his device already, Alan?
No, it didn't
Cool.
get into detail. Just kind of gave the back history.
Cool. So he carried out the coupled shutters experiment for the first time in 1979 in Brussels. The precision achieved with the first experiment was not sufficient for accurately determining the Earth's absolute velocity. Thus, with that experiment, I could only establish its velocity was not greater than 3,000 kilometers per second. The coupled shutters experiment is relatively simple and cheap. However, no scientist in the world has repeated it. Various space-time conferences which I attended or organized, I was like annoyed when I saw the phrase space-time until later on I realized he invokes it differently in a way that's actually kind of sensible. So it lay beyond the expertise of the laboratory to achieve the mechanical. So these people were. This is kind of funny. He says here, I was informed by the Department of Air Force of Scientific Research, Bolling Air Force Base, that Dr. Marinov's experiments were to be repeated by the Joint Institute for Laboratory Astrophysics. On inquiry, I learned that the JILA is not carrying out the experiments because preliminary engineering studies had indicated that it lay beyond the expertise of the laboratory to achieve the mechanical tolerances needed to ensure a valid result. So then he just gets sassy. He says, after presenting my objections that they're unable to do it, he says, if in a secondhand workshop in a fortnight for $500 I achieve the necessary accuracy, then I suppose they can achieve it too. He's kind of mocking them, saying like, dude, I can do it for $500. You guys don't even want to try it? What the heck? It will take very much more than this to change the direction of physics. I suspect that even scientists working in the most reputable laboratories in the U.S. or the world would encounter great opposition in attempting to publish results as revolutionary as those claimed by Dr. Marinov. And this was Professor van der Meer. He had sent that out. And he said, now the apparatus was built not in 7 days, but 4. So he's kind of mocking them more, saying he did it in 4 days. The apparatus was built predominantly over the weekend and cost 12,000 shillings or $1,000. The driving motor was taken from an old washing machine and cost nothing. And there is the apparatus. My first intention was to use as a light source the sun. I carried out the experiment in the apartment of my girlfriend. But the problem he was running into is one cannot be sure whether the observed effect is due to the delay times of the light pulses of the sun's motion, because the sun's moving. So the motion of the sun was making it hard for him to use sunlight. When my apparatus began to whistle, the neighbors knocked on the door. And then after a couple of altercations, my girlfriend threw me out of her apartment. And not only my apparatus, but also me. Since the description is extremely simple and short, I shall give it here, noting that the mounting of the laser and the mirrors on the laboratory table lasted 2 hours. This may not be as hopeless as might appear at first sight, since the difficulties are entirely mechanical and may possibly be surmounted in the course of time. What is he talking about here?
Oh, I'm sorry. I have a shitty setup. It's all I could do. Please listen to me.
No, he's not saying that. He's saying it's not as hopeless as it might appear at first sight. He's saying that it seems like there's difficulties, but actually you can surmount these.
Yeah, I think you're right.
Oh, actually, you can overcome them. Got it. Surmount.
So then he says, Michelson and Morley proposed an experiment which is almost the same as my deviant coupled mirrors experiment. They proposed to use a bridge method with 2 selenium cells, where the null instrument is a telephone. I must emphasize that I could not succeed in finding a single paper or book treating the historic Michelson-Morley experiment where information on their one-way proposal should be given. So, like, that's such an interesting point. It kind of goes back to what me and Alan were talking about over the last couple of days, where it's like, or like they had an idea, like there was a reason that they thought they could measure the absolute motion of the Earth using interferometry. And what he's saying here is like he can't even find them like giving their proposal on how they would do it or anything. Like it's odd that wouldn't be public literature and popular literature at that. So here's his apparatus. Let's see if I can find the best. So I think he'll get into here. So the coupled shutters experiment. A rotating axle driven by an actual electromotor located exactly the middle of the axle has two holed discs at its extremities. By means of a galvanometer, one measures the difference in the currents generated by both photocells. So, essentially, I'll try my best to explain it here. Or actually, Alan, that diagram you had was the best one.
I'll see if I can find it.
Cool. I'll keep reading.
Was it not in the paper?
I don't think it's in this specific paper, actually. You know which one I'm talking about? It's just like a straight up like diagram of how it works from the top down.
Yeah.
I think it was on the site where you got this paper.
Oh, you're right. Let me go look that up.
Was that you in the picture, Alan?
Yeah.
There's Alan. that's Marinov there.
Oh.
With his device.
That's Alan.
So yeah, I'll keep reading here. By means of a galvanometer, one measures the difference in the currents generated by both photocells. I'll try my best to just explain it. So there's a laser. I think that's the emitter here, or maybe the emitter is down here. I'm not sure. But the emitter goes through, and there are crystals here in these holes that essentially he's just measuring the difference of time. So he's got one laser going this way and a detector here, and one laser going this way and a detector here. And by detecting the amount of light that's getting through both holes, he's able to then he looks at the current measured by the galvanometer on both ends, and that current is proportional to the velocity of the light, because these are rotating in unison. So the light has to get from here to here, and in this way, it needs to be getting from here to here. So if the velocity of light is constant and these distances are exactly the same, then there should be the same amount of light getting through both, as long as the precision is good, right? And what he's measuring then is the difference of the light that's of the current of light that's making it to both of the galvanometers. Does that make sense at all?
So he's inducting an electric field around what's happening, and it's changing the speed?
Well, he's just using light, but the galvanometer, I guess, essentially measures the light as like a current.
Yeah, so on the back of that, there's what do you call it, like a photographic plate detector things or whatever. So it registers the light emission as a when it does that, it generates an electric current. So he's using that to measure, or with the galvanometer to measure the amplitude of those currents, right? And then from that, he gets a minimum and maximum frequency. So what he's doing kind of is so take a look at let's see, the section that we're looking at now closest to us on the left. So the laser would be going through that, and as that's spinning, it's kind of like chunking up that coherent beam into sections. So the amount of section that passes through the end receptor at the other end when it's spinning is kind of like what he's using to get the fringe patterns, right? To determine the speed of light. Because is it picking up speed? Because it would have to pick up speed in order to get through and register a fringe, essentially, is the way he has it designed. So if it maintains the same speed, it won't that galvanometer won't register anything, because not enough light will pass through the holes to activate the photographic plates. Does that make sense?
Yeah, so it's diminishing like the amplitude of the light is what you're saying.
Essentially, yeah.
Yeah, essentially, yeah.
Wait,
Yeah,
I've seen that before.
So the directionality, like the ether drift, is changing the amplitude of the light.
I've seen
Yes.
that apparatus before explained it's like somewhere in my subconscious, like on some type of History Channel documentary. Like I've seen that.
Yeah, that suggests like some kind of mechanical interaction between the light propagation intensity and preferred direction drift. Sagnac effect.
Yeah, that's what
Yeah.
they measure.
I mean, that's like
So yeah, so
no
this
wonder
guy
they
got
wanted to
measure.
hide him. Yeah.
Yeah, this guy got measurements, counted up his fringes all the way up to the galactic speeds, and then was telling everybody, "Yo, I measured it, boys." And oh, sorry.
Well, yeah, we can.
If you wanna,
Yeah, I can keep
if
going.
you wanna, yeah, go ahead.
don't
Oh, you
don't
want me to keep
spoil
going?
don't spoil the depressing ending. By means of a galvanometer, one measures the difference in the currents generated by both photocells. If covering one of the cells, one measures the current produced by the other cell. One arranges the position of the laser beam with respect to the disk's holes in such a manner that when the axle is at rest, the light of the laser which passes through the near hole illuminates half of the far hole. With the increase of the rate of rotation, less and less light will pass through the far holes. For brevity, I shall call the first kind of far holes escaping and the second kind of far holes entering. Yeah, much more. His math is pretty interesting, actually. Me and Al ended up, this is essentially Sagnac right here, right? 2 pi delta.
Yeah, he's essentially deriving a fringe shift proportional to the velocity of what he's measuring. So, in the regards of the device being stationary, he's measuring the ether wind. His interpretation, obviously, is that he's measuring the Earth through absolute space at the speeds corresponding to quote unquote galactic speeds. But obviously, that's just from counting too many fringes, because that's what Hector Monera did to get his. And you don't count them like that to get that amount, because there's actually a direct proportional relationship that they use for inertial navigation systems. So like this proportional relationship is a real thing, but if you don't count it right, then it's not meaningful, right? You're just kind of playing.
Right. That's pretty cool.
But so the point is, though, he definitely detected something that was quantifiable because he measured it out to what he could extrapolate as, for the role play. But he did get a measurement.
Was he counting fringes or just measuring the differential in photocurrent?
Differential in the photocurrent.
What are N and R? Do you know what those are? The variables in the equation at the top?
Yeah, the delta N is, let's see.
Rotational rate of the axles.
Yeah, and then the other one was the length of the travel time, I think it was. So it's literally like the same thing as
the breadth. Right there, the breadth of the light spot, proportional to the breadth of the B. So.
Oh, cool. So yeah, moving on. Thus, or much more important, however, was the fact that the illumination of the beam's cross sections was not homogeneous. At the center, it was maximum, and at the periphery, minimum. Thus, the simplified relation did not correspond to reality if, under I sub ham, one would understand the measured current. Now, I am no more afraid of the referee. The illumination will be assumed increase linearly from 0 on the periphery of the light beam to a maximum at its center, where the beam is cut by the hole's rims. And that in this formula, I sub ham dx is the current produced by a strip with breadth dx of the light beam at the periphery of the light beam. So that's this here. According to my absolute space-time theory, if the absolute velocities component of the laboratory along the direction of light propagation is v, then the velocity of light is c minus v along the propagation direction and c plus v against. So he's talking about how he's claiming this to be a measurement of absolute motion. And then he says here, he has his math. He says where delta I plus, is that epsilon? What is this one?
Yep.
Epsilon I and delta I minus epsilon I are the changes of the currents generated by the photocells when the rate of rotation changes. And then he says the light source was an AR laser. The photocells were silicon photocollectors, and the measuring instrument was an Austrian Norma galvanometer. I had to use a big condenser in parallel with the galvanometer's entrance.
Wait, go back up. Let me see that real quick.
So we've got, I'm not sure what this is specifically. The points are the measurements at the even hours for the days. Oh, that's interesting.
Here, go back up.
So that that's the fluctuation in the velocity. Wow.
Yeah, go back up just real quick. Okay. Measurement. Could you read that part real quick?
Measurement of V.
Yeah.
The measurement of c is an absolute, while the measurement of v is a relative, taking the velocity of light c as known. According to Formula 7, one has to measure only two difference currents, 2 delta I at escaping and entering far holes, and 2 epsilon I at escaping and entering far holes. The measurement in the air of the laboratory had 2 important inconsistencies. Dust in the air led to very big fluctuations in the measured current differences, and I had to use a big condenser in parallel with the galvanometer's entrance, making the apparatus very sluggish. The shrill of the whole disk... Yeah.
Wait. Okay.
So I took plus or minus 30 kilometers per second as the uncertainty error in the measurement of V. And yeah, so as for the time of month, the figures do not change significantly. One can compare directly the figures with the figures. The declinations are the same. The reason is I have the intuitive feeling that the figures obtained in Sophia are more near to reality. The reason that I profoundly believe in the mystique of the numbers and my Sophia measurements led to the magic number 300 kilometers per second for the sun's absolute velocity. So this is him. He's making like his assertion that adding the fringes up and getting this number is how he's asserting it. But this is where it gets really fun, because every time we talk about this, we talk about Wang, we talk about Sagnac, we talk about GPS, we talk about all this stuff. They always say, well, then write your paper, refute Einstein, just go get your Nobel Prize. So here's what happened to Marinov. He shows the experiment as childishly simple, as I always asserted, and he says, I wish to add in closing that with a letter of the 29th of December, 1983, I informed the Nobel Committee that I am ready at any time to bring the coupled shutters experiment to Stockholm and to demonstrate the registration of the Earth's absolute motion. With a letter of 28th of January, 1984, Dr. B. Nagal of the Physics Nobel Committee informed me that my letter had been received. So he sent them a letter, and so that was in 1983. And Alan, when was the tragic? When was the tragic
scroll
moment?
Up a little bit.
What's that?
Scroll up just a little bit. So it was. Oh, where did we read that?
It was not in this paper.
Oh, dude, it was okay.
We have to find that, or you can just recap.
When did the thing happen to him?
Yeah, so a year later they threw him out a window after
he jumped to his own peril a year later. He jumped out of a window, they claim, at the university.
Yep. Sorry, yeah, I say they threw him out. What it says is that he jumped on his own accord, obviously from the university library window.
Oh, yeah. And then they committed him because he tried to kill himself, they say?
No, they did that before.
No, he died after that, right? Is that what you're saying?
Yes.
Oh.
Yep. They threw him out a window.
A year later, he...
out a window. Wink, wink.
Yep. A year later, they Epsteined him. Or I don't know. Maybe that's not the right, because I don't even know what that means necessarily.
Dude, so I mean, you know what these people are? Just like you got the cartel that like controls the drugs, and you used to have the mafia that can, would like, take a tax off you of everything. These people are like the super scientific technology pimps, right?
Bro,
they're the cartel for that.
Every time they ice somebody, it's y'all relative.
I mean, bro. So like, if you want to.
They don't give a fuck, bro.
Bro, I bet if you patented technology that would like mess with some of this stuff,
wouldn't even patent it, bro.
No, they would buy it off you and tell you to not talk about it.
What technology?
Young Wang.
We don't have anything.
Yeah, be like, come work for us, and she can make this stuff, right? Like, yeah, okay.
Hey, could you drop a link to that PDF we were just looking at?
Bro,
Marinov.
all you gotta do is do
I'm working
this
on it
research.
right now. I'm trying to figure out which folder. I forgot which folder I have.
Do this research, make a proof of concept, and send it to the military, and somebody be emailing you.
Here it is.
No, they'd be like, no, we already have Wang. You're
Right.
good.
I'd build it and send it to you and tell them you had it. I'd tell them you built it.
It's all relative.
It's all relative. Well, yeah, that's pretty
Dude,
much
that was an
everything.
excellent summary of events transpired and measurements of the ether, the physical measurements.
Dude, I missed the
Excuse
sauce.
me.
I was listening.
Explanations for what do you call it? Pendulum precessions, like that physical interaction. I mean, that's huge, man. Pressure systems, weather, the implications are huge.
Yeah, I'm gonna have to rewatch it because I was working. I tuned in for like a second, but it wasn't. I couldn't hear anything, so I had to fucking.
Bro, the Sagnac effect literally like affects all of everything, bro. It's kind of crazy.
It's really
Well-
crazy.
Like they would have to say, you know what they would have to say to like explain it away, and it still wouldn't make sense. They would have to say light is affecting everything around us, and that makes even less sense, right?
They could say whatever they want, basically. It doesn't matter.
Yeah, it's crazy, bro.
Up to and
Sagnac,
including gravity waves traveling at the supersonic speeds in the atmosphere. Like anything's on the table, boys.
All I know is I want to fucking do some experiments on the next eclipse. I'm just gonna at
Same,
least
dude. I
get-
want to
I'm
do
just gonna-
do pH tests. Like that's so easy to do.
Let's do pH tests and pendulum, and just have like a normal pendulum.
Pendulum, interferometer, pH. I don't know, like really every type of measurement you can think of. Electrical field. Or like
Acts of purity.
magnetic
Acts of purity, especially.
What's that?
Acts of purity, especially.
Oh yeah, that was an interesting point. I mean, that's an interesting thought.
I
Does
mean,
anyone
doing these
have anything
experiments is-
before I close
Oh, go
out the Aether cosmology stream, and then we can just go into like really free flow? Or is there anything that anyone wants to add to the stream?
I'm so glad you guys are doing this. I hope it keeps continuing. I'm gonna definitely catch up. Hell yeah.
Cool. I'm gonna go ahead and close my stream out then.
Cool. I got mine running for now. I'm getting to
Fuck it. Can we
get
free
the
flow a little
general
bit?
afterthoughts.
Yeah,
Yeah,
let's leave it. I'll leave it running.
Okay. Like, no, yeah, dude. The Allais effect. I mean, if it is an effect, right? The only way to explain it would be say, oh, it's just an alleged effect. Like they literally can't acknowledge it. So like I feel like that would be
Dude.
something that needs to be acknowledged if we can get some proof of the Allais effect. type
Well,
shit.
dude, actually, I wish I would have gotten. There was another paper I had come across a few days ago about one of the other papers refuting it, and it's funny because in that paper they took two angles. They called it the alleged Allais effect. So they're like they refuse to acknowledge that it's real, but then they still went out of their way to write a whole paper about how it could be caused by like some kind of gravitational alignment of the Earth and the Sun, or I can't remember how exactly they worded it, but it was just funny to me how it's like
They had a pre-printed story for it already.
yeah, exactly.
That's what makes me so sus about it.
Exactly.
And it's just like, why would they need to make this effect allegedly? And it's like, oh, if it fucks with the precession of things, that throws the idea of relativity out the door. Gone. Bye. Totally gone. Especially if you get light tests like that. Oh, or like just the pendulum swing alone would mean that there's a direct relationship with the forces acting upon Earth, right? And you can measure this shit. So the fact that like you would have to acknowledge that Earth's in the center. Like you would have to acknowledge that it's geocentric.
Yeah, right, dude.
100%.
You think so? They would transform someone out of it, dog. No way.
But I'm just saying, like, either way, they would have to come up with something about the Allais effect. Like, pre-printed, like, you know what I mean? Like, if we can actually prove that it does affect pendulums.
Right.
That's what it was, right? It was him fucking with the pendulum. He was saying he was doing some wild shit with it during
Yep.
the eclipse.
Yep.
Makes it process in the wrong direction
Come
by a
on,
magnitude unexplainable by gravitational effects.
bro. Exactly.
Hey, what's that thing that's 120 times stronger than gravity?
Oh, electromagnetism.
It was 100,000 times stronger, bro.
Oh, 100,000. Oh, my bad.
Yeah, 10 to
Thank
the
you.
5. 10 to the
What?
5. Yeah.
Oh, 10, dude. I often misplace my fives. So yeah, 10 to the 105. You said.
No, 10 to the 5,
10 to the-
which is 100,000.
The old 100,000 difference in magnitude. Classic.
Oh
Classic.
man.
Well, no, I guess they couldn't even
Yeah.
say that, right?
Accounting for
GG.
gravity doesn't work, bro.
I couldn't believe last night that there was a distinction between gravitational waves and gravity waves.
What?
Yeah.
What?
Oh,
Gravitational waves is what they claim. So when we experience etheric phenomena on the Earth that are in relation to phenomena in the sky, they try to claim that as gravitational waves. And then when we experience just normal pressure mediation on the Earth due to just pressure mediation, like that infrasound that's happening from the pressure mediation, they ascribe that to gravity waves, or just gravity waves.
yeah.
Wow.
It's really confusing and utterly pseudoscience.
What are these weird pictures that y'all angles got in the chat?
Good question. Oh, I think this is related to the pendulum precession. I think it's like a time lapse of a pendulum or something.
Is that a vortex? And what is this little like instrument next to it with like a weight on it?
Yo, I wish he was still here.
Oh, that might have been the Oh wait, never mind. Different person.
Did
Who's
they
Jan
use
Angel?
did they do like a pendulum precession on like an electric field next to some dense metal?
I think it's a bottle drooling ink.
So the pendulum precession effect was measured in like a magnetic field inducted next to an object? Is this around a giant like ferromagnetic stone?
No idea.
Oh, I was muted. I was saying we should probably ask him before we start guessing. Could just be art.
We're just wildly speculating. Yeah, let's start
Yeah.
making math equations to reify our presuppositions about it.
Oh my God. I was like, wait, we should ask.
Man, we still need to get into that. I don't want to do it right this very second, but that, was it the Thompson precession, or what's it called?
Oh, Thomas perception. Thomas precession.
Yeah. And
Yeah,
then there's
that was a
also this
wild
paper
ride.
that got dropped earlier I want to dig into still. This where is it? The light speed versus the observer, Kennedy Thorndike. But I haven't even started looking at it yet.
I knew that was Alan. I was like, did Alan just yawn from like 10 miles away?
Sorry, I tried to lean back as far as I could so my mic wouldn't pick it
Dude,
up.
I love-
It was like
I really like that when I brought up this Kennedy Thorndike test, it made you yawn.
well, he changed the link to the apparatus and then declared that Miller was defeated. So, like, GG.
Of course. Well,
Sorry
geez,
about that,
man, I'm gonna close the stream out then.
Yeah, I'm about to close out mine. I'll be right back.
Well, geez, we made it 3 hours, not bad. Or 2 hours 45 minutes. I think we covered a lot. Thank you all for listening.